5 startups, 25 projects funded by the Horizon Europe, emerging industry, new value chains boosted by small flying objects. It's a mouthful, I know. We like to call it UFO. It's good to see you all here. Thank you for coming. My name is Luca Budello, and I lead on geospatial at Innovate UK KTN. Today I'll be chairing the event together with my colleague Andy Bennett, who is a KTN very own space expert. Now I need to move the slide, for example. Let's see it, right? No, it's not working. Well, we have a packed day of events today. We got a series of talks, pitches, networking opportunities, drinks, and we even have a prize ceremony at the end. But before we get started, I'd just like to thank a few people. First, Virginie Perron, which is here from the European Innovation Council, and will provide a welcome message on behalf of the European Commission. Then I would like to thank our keynote speaker, Aravind Ravichandran from TerraWatch Space, Donna Lindsay from Ordnance Survey, and Nick Appleyard from the European Space Agency, whom knowledge of the market opportunity in Earth observation and the use of location data for generating positive social and environmental outcomes is second to none, and I really look forward to their insights today. I also like to thank our partners in the UFO program. We started the program 2 years ago, and today is the last event, last day of some phasing event of the program, and I only met everyone in person last night for the first time. It is wonderful to have you all here today. Thank you very much for coming. Thank you very much for supporting the SMEs, for the discussion that we had, the idea that we stormed, and also the disagreements that we had every now and then. Finally, I'd like to thank our KTN, my KTN colleague, Viola, who literally works her socks off, and I'm sure now is very stressed because of what is happening, to put the event together. So I'd like to thank you on behalf of everyone here. Thank you, Viola. Now, the Royal Geographical Society was founded in 1830 to promote the adoption of geographical sciences. And today we're going to talk a lot about geography, particularly geography at the intersection of science and practice. And when you do this, when you do knowledge transfer, you need collaborations. You need collaborations. Innovation is a collaborative process. And the partners in the UFO programs, through the collaboration that we established, have allowed 66 SMEs to form a pan-European cross-border partnership. And we are here today to celebrate the innovation that they have created throughout the program. So we want to see more collaboration happening today. We want to help these SMEs also to connect with you, with the members of the audience here today. And for this, we have used a program which is called, now I forgot the name, Meeting Mojo, thank you very much, to create more networking opportunities. I'm sure many of you have received an invite for a meeting. Please go and check your account, accept the invite, propose new invites so that we can collaborate more together. Now, a few housekeeping for the day. We are not expecting any fire drill. So if the alarm goes off, please familiarize with the closest emergency exit. This event is actually hybrid, so I am being filmed as we speak, as I speak. But also camera will be on the ground today, so if you don't want to be on film, please let us know. And also today, those that are following us online from wherever you are, welcome to the UFO Showcase. Now, enjoy the day, find inspiration, meet new people, make new connections, invest in startups, and let's innovate together. First up is Tade Bouchard, EU Space Lead for Aerospace Ballet, who will introduce us to the UFO program. Thank you very much.
Thank you very much. I hope you liked the video. It is indeed one of my favorite videos ever, because of course it speaks of the UFO project. Thank you very much, Andy. Thank you very much, Luca, for the kind introduction and also for hosting us today. Welcome everyone here at the UFO Showcase event in London. It really is a pleasure for me to be with you and to see all of the participants. And I cannot say it again, because it really is a pleasure to see you. We are all gathered here around our common interests into the small flying object, and it is an honor to introduce the final showcase event of the program UFO. Welcome. So now, this is the agenda. Nice slides, though. Okay, so here it is. So first I would like to give you details on the achievement of the program UFO. But before going any further, I would also like to make some personal thanks to the partners that was introduced, and let me name now them. So we have from France our partners from Mineralogic and Finance Innovation. We have partners from Greece, Coralia. We have from Romania, Cluj IT are with us. We have from Bulgaria, ICT Cluster. It's a nice delegation. And we have Innovative UK, KTN, and also Marine Southeast from the United Kingdom. Thanks for being with us. And we have also the chance to include in our partnerships Climate Kick as an associate partner. So thanks for being with us today. You really were 100% devoted to the project UFO from the beginning to the end. And I cannot say how much I am grateful for that. You made this day possible, so thank you very much. A special note to KTN, of course, Luca and Andy were here, but also Vaira, who unfortunately left the room just 2 minutes ago, but I'm pretty sure I will have the opportunity to thank her again. So it was really is a wonderful accomplishment to see everyone in this beautiful venue, and it's really nice to see you here. A special thanks to the Royal Geographical Society also for welcoming us. Thanks. Additionally, Virginie, it is also a pleasure to welcome our Executive Agency for Small and Medium-Sized Enterprise Project Advisor. Thank you for being with us today. It is also a pleasure, Nick Appleyard from the European Space Agency. Well, we have, of course, Dr. Donna Lindsay from Ordnance Survey with us, Aravin Ravichandran, founder of TerraWatch. Again, I would like to thank you. And to finalize, of course, all the participants, I'm very sorry if I forgot someone, thanks. Please, if you're online or if you're here today, know that all kind of involvement that you've provided to Project UFO were truly appreciated, from the beneficiaries to the organizer. Thank you all. So now I think I can go on with the information on the program UFO and why we are here today. So for those who are not familiar with what we have done, and for those who participated at some point, or just for a lapse of time, I think it is important to propose to you and to present to you the achievement that we have provided to the high-altitude platform system industry, to the drone industry, and to the space sectors. So we know that with the newly established EU Space Research Program, we know that the space sector is for the European continent not only a source of strategic interest, but also an important market for its people. The EU Space Program aimed to have a stronger impact on startup and SMEs to support the emergence of a European new space economy. Between 2014 and 2020, the EU alone invested over 12 billion euros in space activities. So it helped to reinforce the European sovereignty, to prepare ourselves to face the climate challenges, and to contribute to innovation of tomorrow's life. And this is why we have formed the consortium UFO, and we have proposed this project. The goal was to foster the creation of innovative end services that are combining new technological solutions, such as nano or digital technologies, in the specific and dedicated small flying object. As you can see here, we have extended the definition of a small flying object to the drone, the high-altitude platform systems, here's the balloon, and with the small satellite. So within the framework, here. So within the framework of the European Commission's program, we had the proper structure to contribute at our level to those sectors. With the partner, we apply and get the coordination of an InnoSup1 project from Horizon 2020. So as some of you may already know, this kind of program acts as a cascade funding scheme program, which means that we receive more than 4 million euros with the key mission to redirect at least 75% of that funding directly to SMEs in order to finance inter-European collaborative projects. So with this task, we structure and launch 2 open calls of 1.5 million euros, where we directly ask the SMEs to propose a solution in a consortium to improve the value chain of 6 targeted emerging industries. So as mentioned before, the goal was, of course, to enhance the European competitiveness in those sectors. So the small flying objects, we believe that they are essential to the European market as it presents the most cost-efficient solution for the collection of high-quality data, and if it is, of course, supporting the European key priorities for tomorrow. So just to name those industries, even though the majority already know them, we identified them based on our daily needs, which are the mobility industry, the climate and environment one, the blue growth, the finance and insurance, the digital, the creative and the gaming industries. So at the end, more or less, it is something like half the project that we have financed that include at least one element based on the environment or climate aspect. I wanted to bring that statistic to you today because I really believe that it speaks for itself. So to this end, it is more than 3 million euros that we have dedicated only to the direct funding of new innovative projects. It is 66 different SMEs from Bulgaria, France, Greece, Romania, and the United Kingdom that benefit from this European program. That funding helped to foster the creation and the improvement of 25 new value chains, and will be presented today to you, because you are lucky, 22 out of those 25 projects. You will see 20 projects of demonstration and 2 projects of feasibility study. And they are all, without any exception, led or including very enthusiastic entrepreneurs. So this is something very fantastic. So for your information and to give you an idea of the work that we had the opportunity to fund projects from a wide range of European countries. And we have Greece, France, and the United Kingdom being in front and followed by Romania and Bulgaria. One element I would like to say is actually our UK partners really played the game of collaboration and worked very hard to connect SMEs from the local industries to European one. And really, this is the kind of collaborative spirit that emerged from European project. So speaking of European project, this is something I would like to say about them and why I really believe that they are an interesting and very promising mechanism. We all know that the EU funding mechanism can be very heavy or can be seen as a very time-consuming action. But we all know that the cascade funding is a great opportunity for those who are not used to the European project. And I really believe that the European project and the European idea is a very good first step toward all kinds of European support activities that exist. It opened the door directly to SMEs, and it paved the way to a more direct collaboration between the EU institution and its citizens. I spent the last few years presenting this EU funding mechanism to the enthusiast community, and I personally enjoy spending time explaining it. I met a lot of people very eager and open to work with the European Union, and they just needed a bit of support from us to begin the process. And this UFO program was the main tool for this. So to go back to our project, You will see today the project going from maritime autonomous landing drones to 3D scanning solution of cultural heritage monument to the demonstration of AI embedded in small satellite. But this event, as presented by Luca, it is much more than just a presentation of those projects. We really aim today to support the sustainability of those projects and at the same time to propose to you, participants, mature and innovative solution to face the challenge of your industry. So to conclude, one aspect I would really bring the emphasis on is I would like you to invite very much to exchange with each other, to speak and to reach out to the customer that we have the chance to meet today, and to see all the exhibition booth that we have on 2 rooms upstairs. Very nice arrangement on this. You may have some synergies between you that you didn't think you had before, and this is the opportunity to see them. So go meet the end users, the private investors, the public actors, and also all of the UFO participants with the consortium that I presented earlier, because as you can see, there are other funding mechanisms that exist, where of course there's always a way to make it eligible for you. So as an example here, what I bring to you, we have a bit like UFO, but somehow different. It's named the Euro clusters, where it includes some part of financial cascade funding support. I will say that we have Cluj IT from Romania here that are partnering in 3 different Euro clusters, so go see them. We have Corallian Aerospace Valley also participating in another one, the Metastar. And one that is not on the slide, but I think very important too, is coordinated by our partners from Bulgaria and France, Minalogic. Really go meet them to get more information on what the European clusters are, because they do not only target the countries where they are established, it really is open to all of Europe. Additionally, there is the other mechanism named the European Digital Innovation Hub that can be interesting for you. So if you go see the local partners, then you get more information on those hubs. And finally, one of my favorite initiatives that I really like is what we call the National Contact Point, which is a program that dedicated to one person in your country that have an extended knowledge on the European cause. And that person have the key role to give you more information on the call, but also to guide you from the process of applying to all the process in going from applying to the acceptance, obviously, of this project. So really go meet that person, go have an exchange with that person and really get more information of all the European cause that exist, and this national contact point is the first door to it. So on those words, I will of course wish you all a wonderful day and of course a successful event. Thank you very much.
Thank you very much, Tadej. And now we're going to have Virginie Perron to give us a message from the European Commission.
So, sorry, just to move the slides. Just press on next.
Just next, yes.
Okay, thank you very much. So, good morning. So my name is Virginie Perron. I am a project advisor in the executive agency for the European Innovation Council and Small and Medium-Sized Enterprises. I work in close collaboration with the European Commission, of course, DG GROW, which is our parent DG. First of all, I would like indeed to congratulate the UFO Consortium for the great achievement, but also the SMEs who developed all these innovative solutions. So in Brussels, we must say that we are very happy with the results. But the thing is that UFO is now coming to an end. So the purpose of my presentation, yes, is to present to you new opportunities you may get from other projects, from other programs, that could be in complement to the support, so financial, but also non-financial support you got from UFO. So Tade has already mentioned some. I have other examples, so it's good. But first of all, so this is the content of my presentation. So to start with, actually, I would like to say a few more words than Tade did on the InnoSup1 action, because it's a big action that was launched actually in 2016. So it's the cluster facilitated action, facilitated projects for new industrial value chain. So the purpose of this action was really to develop new industrial value chains by supporting the collaboration of different innovation actors, essentially SMEs, but large companies as well, from different sectors and from different countries. So in total, we supported, since 2016, we supported 29 projects. All similar to what you knew with UFO. So the average budget, well, yes, the average budget was 5 million euros for each project, and we expected from them to give financial support to SMEs to develop these innovative solutions, but also coaching, mentoring services. And it's true that for each of these projects, we expected that at least 75% of the budget would be allocated to support innovation, with the limit that an SME cannot get more than 60K. As we said, these are cluster facilitated projects. So why did we rely on clusters? If we take just UFO, all the partners were clusters, whether it was Coralia, KTN, Aerospace Valley, Minalogic, Cluj IT, etc. Because we think that clusters, they offer a favorable ecosystem. We know that they host innovative companies, that they reach out to groups of related SMEs, that they are well positioned as facilitators and bridge builders, and that they create strategic partnerships at the level of policymakers and intermediaries, and of course that they provide customized business support services to their SMEs. So on this slide, I don't know if you can really read well, but I just wanted to give you an overview of the sectors that were covered by these 29 projects. So we see, you will see that there are quite a lot. So myself, I'm not an expert in aerospace, aeronautics, because out of the 29 projects, I was managing 18, covering all sectors. So I'm really a project manager. So don't come to me to ask me anything about aerospace. I won't be able to help you. But still, we see that all these projects, they were cross-sectoral, so involving more than one sector. So you see that out of the 29, 26 had an ICT dimension, were about digitalization. But then you can see that we had, at the top, we have aerospace, so we had 10 projects addressing somehow aerospace, and then below we have 3 projects that addressed at some point Earth observation. But as you can see, there were many sectors covered. So in this slide, it's just, all the logos of the project. And then in this slide, I just mentioned really the projects that addressed sectors that may be of more interest to the people in this room. So space aeronautics, Earth observation. So we still have 4 projects ongoing. So UFO, Amulet, Galactica, Galatea. And we had 3 projects that closed, but the results and the SME solutions developed are still available if you are interested, for instance. I guess you will have access to these slides, so if you want to find out more about these projects, you can click on the link. So just an overview of the key outcomes of these InnoSup1 actions between 2016 and June 2022. So thanks to the 29 projects launched, it's more than 86 million euros that were given to SMEs in funding or in service provision. And it's more than 4,200 SMEs from 40 different countries that received this support. So quite impressive numbers, I think. And then if we look at the countries, so in this slide it's the number of SMEs with funded proposals per country. So we see that the largest, it's in Spain that the largest number of SMEs were supported, followed by France, Italy. And in the next slide, it's the amount of funding given to each country. So it follows a bit the number of SMEs. And it's in accordance, I would say, more or less with the size of the country as well. But you see, it's a lot of countries covered. So this was really the overview of this InnoSup1 action. But it's true now, I'm going to say a few words about cascade funding. So the SMEs present in this room, you receive funding, maximum 60K from UFO. And it's true that cascade funding is becoming more and more popular in Brussels because we see many advantages with that. So we, the European Commission, we give a grant to intermediaries, consortia, like UFO. And then they organize sub-calls for third parties. And we know that for USMEs, usually there is far less competition than if you would apply directly to the European Innovation Council in calls or any other call, that the formalities and the administrative burden is much lower, so that you get the money faster. And usually the feedback we get from SMEs on cascade funding is quite positive as well. So there, I've put on this slide a link where you can find all the cascade funding opportunities published by European projects. So you will have access to the links on this page. And then I would like to, I have a few examples. I have several examples. I'm not going to detail all of them because it would be too long. But I just wanted to highlight some calls that will be published in the next few months. So the first one is from Amulet. So Amulet is an InnoSup1 project as well. So it aims to foster the penetration of lightweighting materials in decarbonization and resource efficiencies for circular economic cuts across different industries, automotive, aerospace and aeronautics, energy, and building sectors. So this is really about lightweight materials penetration in these sectors. And they will publish their second call. Actually, it won't be in January, but it should be around the 20th of December with the budget. So the budget is 1.14 million euros. So SMEs from the EU member states and H2020 associated countries will be eligible. So I would like to insist that these projects are funded under Horizon 2020, meaning that UK SMEs are still eligible compared to new programs. So maybe this could be interesting for you. So the approach is a bit different with this project than with UFO because it's a funnel approach. So first, SMEs have to apply. Then if they pass the first stage, they get a grant of 23,000 euros to prepare a feasibility study. Then there is another selection. If they pass this stage, they get 80,000 euros per project. So each project has to involve 2 SMEs, and they can develop a prototype, and so on. So maybe this could be of interest to you, to some of you. Then we have Mind for Machines, which is not directly addressing aerospace and so on, but it's more for the manufacturing SMEs and digitalization. So they will also publish a second call in January. And here it's different types of support you can apply to. So there will be vouchers for testing and validating. So it's 60K per project, or you could apply for demonstration and scalability projects with a grant of 30,000 euros per project. So then there is another example with another project, which is about advanced manufacturing assistance and training for SME transformation. So if you're interested, you can go and look at the website. The deadline is quite close. It's on the 14th of December. Then there will be some opportunities as well under the Startup Europe calls. So which the target there is really digital and deep tech startups. So the first calls for cascade funding should be published early next year. So I don't have more information at that stage, but if you are interested, you will be able to follow that on the ASMEA website. Then I also had 2 slides on Euroclusters. So Tade has already mentioned this new big action that was launched this year. So we have 30 projects that were launched, each of them with a budget of 1.5 million euros. And it's at least 75% of this budget that has to be distributed through cascade funding and to support all these activities. So it will be innovation, yes, but also training activities, going international, and so on. So there are 14, the Euroclusters are divided into 14 industrial ecosystems. So some of them are in aerospace and defense, but you see there are many others. But I'm sure that if you have questions on Euroclusters, you can go and ask Tade. He will be able, and the other colleagues from UFO, they will be able to answer the questions better than me. And then just 1 or 2 slides about other support services that you may get, non-financial ones. So for instance, there is this call, in case you are interested, with the S3E, Southern European Entrepreneurship Engine. So it's a call for services. So it's not a call for funding, but if you are interested to improve connections and efficiency of the entrepreneurship ecosystems in the Southern European countries, then you can apply by the 10th of February and get services related to training or relating to mentoring and networking. And then there is also maybe something that could be also of interest, the IP pre-diagnosis. There's a typo there. So you could get for free this service from the Horizon IP scan team. So it could also be interesting. So you can click on this link if you are interested to get more information. And finally, I also wanted to say a few words about the Enterprise Europe Network. I don't know how many of you are aware of this network. It's the biggest business support network in the world. There are branches in every country, and it's really not limited to EU member states. So you can always contact your local branch of the Enterprise Europe Network, and for free you can get advice and support on innovation, sustainability, resilience, finding partners, digitalizations, and internationalization. So I guess this was my last slide. Thank you very much. Again, it's just a few examples. There are many more opportunities existing, but I hope it was interesting for you. If you have any question, you can always come and see me during the breaks. And then I wish you a good day, and I'm looking forward to meeting you as well, the SMEs, and to see what you have done in the past 2 years with the support you got from UFO. Thank you very much.
Thank you very much, Virginie. That was an excellent overview of all the schemes that people can get involved in going forward after these projects end. So, moving on to the next set of talks, we're going to have 3 really excellent talks from 3 fantastic speakers coming up. And with Viola's permission, I'm going to keep the same time, and we're just going to run into the coffee break a bit late, and I think we'll catch up the time later. So we're running about 20 minutes late, but I think that's absolutely fine. We've got plenty of flex in the schedule, which is brilliant. Okay, so yeah, I should also introduce myself, shouldn't I? Yeah, Andy Bennett, I'm the space lead from Innovate UK KTN. So if you've got any questions about Earth observation data or launches happening from Cornwall, then do give me a shout in the breaks. But first off, I'd like to invite up Nick Appleyard, who's our first speaker. Nick heads up the Space Solutions Department at the European Space Agency. And this is the part of the European Space Agency that helps build new services and products and serves customer needs with space capabilities. And also, it's how it helps small businesses to grow and support the burgeoning European space industry. And we're delighted to have you here today, especially given you've had such a busy time with the ESA ministerial recently and so forth. So thank you very much, and please come up on the stage. There we go.
Thanks, Andy. I have to say it's nice to be on this stage, and particularly thanks to the KTN for the invitation. It's like old times for me because I have a background in Innovate UK and working with the KTNs and so on. But no, these days I'm in ESA. Some of you may be familiar with our building on the Harwell campus. Just head west until you find the flags. That's where one of my offices is. The other one's in Estec in Amsterdam. So I head the department in ESA which is most concerned with commercial outputs and the uses of all of the space capabilities that the rest of the agency is investing into. So I'm the one who has to go and find customers and investors for things. A week ago, this is the view from the Grand Palais Éphémère in Paris, which is a very nice venue, the most expensive venue we could find in Paris. Because when you turn around from that photo and look the other direction, we have this very wonderful hall. And some of you, those of you experienced with the European Commission will be familiar with these kind of situations. We have them also in ESA. There is a desk there for every country who is a member state of ESA. We do this particular meeting once every 3 years, and it is where we ask the ministers of all of those countries for new money to continue the European space program for the following 3 years. So this has been very much taking up our attention over the past weeks. So you may recognize some of these people from your own countries. We invited them first each to speak about what they were expecting from their investments into space. Because we're about to ask them all for money, we thought we should probably ask them why they were giving us money. And it's very interesting to listen that we gave them 3 minutes each, kept them very strictly to time, not easy with ministers, and tried to pull out from them what are their priorities, what is it that they want as a return from the public investments they're making. And it was fascinating to hear. For example, I mean, if you listen in Bulgaria, first key word he said was CubeSats. That's interesting. And then talked about the SMEs and the small business growth which is associated with the development of a new space economy in Bulgaria. Listen to the minister from Greece. The first word he said was security. And then he said security, 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 security. And so, okay, security, we understand, fine, yeah. In Romania, it was about IT, and it was about AI, but then it was about the application of those into sectors like energy, and again, security, and into the issues facing the country at the time. So we listened to each of these ministers in turn. 27 times 3 minutes. And really, it boiled down to 4 things. So a lot of them talked about the inspiration value of space. You invest in space, and you get astronauts. And we didn't miss the opportunity to announce the new astronaut cohort to these guys, right, to push that message of inspiration. You get exciting new technology. You get things that you can talk about at the kitchen table to your family, and they really understand why there is value in these investments. Many of the countries are concerned with the security and the external threats and the disruption to the European economies which have been happening over particularly over the last year. And this is clearly preying on a lot of people's minds as they think about how to use technology to solve the problems of the world. But the idea of sustainability is still very strong as well. And this was a key message brought forward from country after country, that we're using space to support sustainability. These images are some of the climate variables and some of the Earth observation outputs which ESA's own Earth observation efforts collate. So many things that we can now monitor from space at a global level, all the way down to the level of individual buildings, individual vehicles, even individual trees. So we really, the whole of climate science sits on a foundation of space data. And I think all the governments are very aware of this. And then the last point which kept coming through was this point about business, right? You're investing the public money into industry, you're investing into small companies, you're investing into job creation, exports, revenues. And that was it, really. So we spent 2.5 hours listening to all of these guys, and they essentially, between them, they said 4 things. So there's those 4 things. So then we went out into the hall, and we mixed with them. And here was the game for the next 2 days, is you have to, Minister, I was very interested to hear what you were saying about sustainability, and can I just take some money from your pocket and put it into my pocket? So we spent, and I invite you, by the way, to practice this maneuver with me in the breaks earlier, because now about 1% of the money which we managed to extract from them is now in my pocket. So come and shake my hand and try and take some of that from me as well. Let me go back one. So here, I'm really looking forward to hearing some of your project reports and outputs here. And really, we're talking about these two, the sustainability and prosperity axis of this. That's my favorite corner as well. So I'm very happy to be here to hear from you. One of the things that we have to try to achieve then is to do more than one of these things at the same time. How do we address more? We can address sustainability, let's say all of the climate science Earth observation work which has gone on. That's great. But can we do sustainability at the same time as working in a business environment and pursuing prosperity? So this is the kind of the challenge which I have and which I put forward to you. Some of the things that we presented to those ministers, one which sits in my directorate, the directorate within which I sit. Moonlight is the name of the project. We're going to set up broadband on the moon. We just got the funding to do this last week. So now we're going to build a team of engineers, and they're going to build some satellites and with the industry, and we are going to set up a data communications infrastructure on the moon. And the task I have within that is to say, well, what is going to be on the moon, which will be customers for this infrastructure? How do we build a lunar economy? How do we make a business environment which links to that piece of infrastructure? For me, that's the most interesting question. On the inspiration side of things as well, we talked about the Space Rider program, continuing that one. This is a reusable, returnable laboratory in space. You load your payloads onto there. You take them up there for a zero-gravity flight in the space environment. You bring them back down again. You may well be aware there is a bit of a problem of traffic management in low Earth orbit. The Adrios mission. This is the ClearSpace spacecraft, which we're already putting some support into, based out of Switzerland. And it's the real Bond film stuff. Right? You've got a dead satellite up there, you go and you take it and you throw it into the Pacific. That one got them excited. Aeolus, measuring wind speeds in the upper atmosphere using laser reflectometry. Truths, providing a calibration standard for all of that climate measurement data that is increasingly being used. I was speaking to a financial services audience yesterday, and they're saying what we really need is data on which we can set investments decisions. But that data then needs to be of a quality and a reliability that we can really trust if we're going to put money on top of it. So the idea of truths is that we provide a calibration standard for the climatic and environmental measurements so that they can have that confidence. So that's just a sample, a subset. We did okay. We got 17 billion euros out of those guys for the next 3 years. So we can be happy. And we're working at all the different layers through the stack. And ESA had to make a decision a few years ago as how far down did we come? Did we come below the Kármán line in our activities? We decided yes. So when we talk about HAPs, they are high-altitude pseudo-satellites. It's okay, the satellites, it's space, it's fine, we can invest into that. And when we talk about drones, we talk about the fact that they are guided by GNSS systems to go wherever they are, so this is part of the space ecosystem, yeah? So this is all space in our definitions, and we put our arms around all of it because it's all, these technologies are all complementary to one another. We see the whole technology system working together. We're very conscious about the revolution which is happening across the space industry at the moment, and the shift across to smaller and smaller satellites, cheaper, faster, this new space language which is coming in now. And the very high numbers of satellites, which are small sats, microsats, and nanosats, which are being launched. Let me come back then to my point about sustainability and prosperity. This is a slide I drew in my first month at ESA when I was talking to my own team and said this is how I kind of see the link between the public benefits which we create from investment in technology and the commercial aspect of this. And put them on two axes. Let's imagine that we could actually quantify and measure these things and plot them onto two axes. It costs money to develop new technology. There's a capital expenditure, there's an R&D expenditure to build your new system. If you then offer that to customers and they pay you for it, you can generate revenue and you can generate a commercial return from it. And if that commercial return goes past the red dot, congratulations, you've made a profit. Congratulations, you are a sustainable business. You are now independent. You no longer need the public money. Thank you very much. We wish you luck. Please go and grow. But at the same time as this, you can be creating a social benefit, an environmental benefit. You can be creating that inspiration that the ministers like. And that is a good use of public money. So then we have this interplay between public investment and private investment. Public investment certainly is easy to justify if it's taking us in this direction. Public investment is also easy to justify if it is helping you to get in this direction past that line of profitability, after which we will be looking for an exit. So science is great. Science is up there at the happy face at the top. That it uses money and it turns it into public benefit. But what we'd encourage you to do, which you're already doing, is actually to think of this as a business opportunity and to move past that line into the big smiley face at the top. And when people make project proposals to us, which sit down here, this is how you don't get through ESA's selection process. So the customer segments that we deal with, my program area, you see where we see the business opportunities. And you can read through all of this, you can read that public benefit, which is coming through the investments which ESA makes, largely with SMEs. 3/4 of this is investment into SMEs. And SMEs who are working already with the customers that they have in mind for their future businesses. Obviously, a large area for us is mobility, transport, logistics, things which are moving around on the Earth's surface, and we need to maintain a connection to them. We have a lot of work in maritime industry and aviation, also in land vehicles and connected vehicles, which links into our 5G program. But also in all of these other areas where there is infrastructure and assets and people spread around the landscape, and we want to provide information about what is happening around them, and also to communicate with them in and out to enable them to run better services. And better includes profitability and it includes sustainability impacts. My portfolio is about 200 of these projects a year. The average size is about €500,000, and we would normally pay half of the cost of that. So this is a natural next step onwards from the UFO projects that you've just been doing, and I invite you to come to us and propose your next step of expansion of your project ambitions. And if it fits into one of these categories, that's great, but you'll see there's a number of wedges of the pie right up the top there, which allow us to actually work across anywhere across the economy. We're very conscious then about this link between investment for profitability and investment for sustainability. We just put together a green dossier, actually the second edition of our green dossier. We updated it from 2 years ago because we doubled our portfolio in that time. And you see the kind of numbers which are in there. I think this adds up to €150 million of investment into SMEs working on sustainability topics with small satellites, drones, aircraft, a little bit of HAPS in there, mobility on the ground, in energy transition, in environmental services, in financial services, in mobility, the things that you're doing. So we are very much investing into the same areas that UFO has been investing into. I have a few project examples, but I think in the interest of time to try and catch up, I will leave it there. We can talk about maybe specific projects and things that we've invested in later on the panel if you're interested. Okay, so thanks, Andy. Thanks all for your attention.
Thank you very much, Nick. I think you twice mentioned that people can come and get money off you, so that's an invite to everyone here in the audience, I think. Okay, we will have a Q&A after everyone's spoken, so please do think of questions, and that includes those who are listening in online, because we can get your questions as well to the three speakers. So up next, I'd like to invite Donna Lindsay. Donna is the Strategic Market Lead for Environment and Sustainability at Ordnance Survey, and Vice Chair of the Space for Climate Group as well, which aims to put the UK at the forefront of global efforts to create and use trusted satellite data for climate action. And she's also a Women in Innovation finalist and also a Fellow of the Royal Geographical Society, so this is a home from home for you. Welcome, Donna.
Thank you very much. It's a real pleasure to be here today to bring us all back down to earth, as we're going to be talking about what Ordnance Survey actually does in terms of the utilisation of space, but also in terms of these new capabilities. And actually, it's really interesting to listen to Nick actually talking about what those core use cases are, because Ordnance Survey itself actually originated from security. We are probably the only entity today here who started in 1791, which was before the RGS, so we've been doing this for a long time, but we've also been innovating for a long time as well. And actually what we do today, so most people are really familiar with us in terms of our paper maps. We have about 4 million customers in the UK using those. But today we actually use it as part of our digital infrastructure. We make 20,000 daily updates to our database of 500 million landscape features across Great Britain. And to do that, we have 230 surveyors who use GNSS and satellite signals to actually help them do their work. And we also have 2 aircraft that take 120,000 aerial images every year to help inform our data capture program. We also have AusNet, which is essentially a network of 110 GNSS receivers that actually enables us to do really high accuracy positioning across the UK. So we do a lot of stuff that incorporates land, people and space. And actually, as we've already heard, the market for this type of capability, particularly SFOs, is going to be huge. To enable us to monitor and map and understand what's going on the land is actually absolutely critical, and we need to do that at the best quality data that we can do. And a lot of this sensor evolution is really key to help entities like us understand what's going on in the landscape, but really help us improve our efficiencies going forward. And you can see here, there's all this stuff online, which I'm sure you're all familiar with, but essentially the markets are growing between 14 and 20%. So, there's a lot to go after there, particularly in that prosperity space that Nick's already talking about. And of course, it's all these use cases that we already know. But from our point of view, we've been trying to apply it in terms of what should a national mapping agency be doing. So I'm going to be talking to you now about a series of use cases that we've been exploring within Ordnance Survey to really help us understand that particular area. And again, it's about also ensuring we can flow the capability across different market spaces. The Ordnance Survey data itself unlocks billions of pounds worth of investment in the UK to date. So again, we have very good connections into all these different markets to grow them. So one of the key things, of course, we have all our surveyors that I've just talked about. We like putting them in relatively dangerous situations, so that's not a good thing. So we've been exploring the use of drone capability to help us capture the data more effectively and safely. It's been particularly useful in terms of the coastal applications, and again in the UK, particularly on the East Coast, we have a lot of erosion activity. So again, we need to really understand what are these changes going on and how we can apply them and update them to our mapping. The other thing we also have is a requirement under our agreement with government. So we look after the Crown data asset for the UK. And as part of that, we have to give updates as to changes in the landscape every 6 weeks. So that's quite a big ask. So one of the things we're doing is using some of the drone capabilities to help inform our surveyors and our databases as to where those core changes are happening so we can update them quickly. The other thing, of course, is that when you go and need to collect data, it's not always the best optimum situation. So this is one of our science friends out there collecting data in terms of flux tower measurements, etc., not the best conditions. So we've been looking at how we can actually help some of these more novel uses of observation data to really help inform some of these core needs, particularly when it comes to monitoring services. And these areas are vast. So as the National Mapping Agency, we have to do things on a landscape scale. We can't do things looking at things just in small areas. So we've been looking at how we can apply certain capabilities like drone capabilities and different sensors to really understand things at a landscape scale that is really difficult to send a surveyor into. So this is actually a very dry peatland. It's normally very, very wet. So to send a surveyor out there to look at the habitat is actually quite difficult because they'll sink, essentially. So to do this on a large scale, we need to really understand how we can do that really effectively and efficiently. And again, that type of thing then enables that unlocked finance, because we know there is a lot of green finance out there waiting to actually invest with confidence into some of these things and to give them that confidence and actually knowing that the data is of good quality and sufficient quality for them to trust. So we've also been looking at how we can actually utilise Earth observation capabilities as well. We've been obviously looking at the Sentinel-2 data series, again, using these type of capabilities that enables us to do change analytics and enables us to be far more efficient in terms of targeting our surveyors and activities. The beauty of these type of sensors is actually, it's not just the ability to get more timely inputs to our databases, it's actually all the different spectral characteristics as well, which we are really looking to understand how that can be really useful for a national mapping agency. The critical thing about that is it enables us to really identify key features in a much more efficient way. And I'm joined here by my colleague Jason Hopkins, who is our subject matter expert. Jason, give us a wave. Thank you very much. Jason's got some great stories about submarines, by the way. Again, we can start building out a picture as to how change can inform our national mapping programs. Jason has been building data cube capabilities within Ordnance Survey to really help us understand how we can mobilise these capabilities. And then it enables us to target and enables us to review our data capture programs and to be far more efficient in our understanding of the landscape change. The other things we've been exploring is hyperspectral capability. Again, with the satellites, we've got a number of bands, but actually with hyperspectral, we've got many, many more. And what this does is it enables us to take better understanding of actually the footprint, the characteristics of the land and the features. So with our aerial program, we capture in red, green, blue, and near-infrared, which gives us some indications of species and types. With the hyperspectral from all the spectral characteristics of satellites, we can gather a little bit more. But actually with the hyperspectral, we can get hundreds of bands of data, and actually that gives us a really good understanding of actually what is actually on the landscape. And that's the type of capabilities we've been exploring. So Jason here has actually been working with the University of Tasmania on a sensor that enables us to capture this data for understanding habitat and vegetation change, and actually exploring how that can be deployed for a national mapping agency. And again, we've been exploring how we can use machine learning on these type of applications as well. So this is an application trying to understand how we can identify key features that are potentially on a peatland, These are really, really hard to identify. I don't know if any of you guys have tried. Yes, somebody's nodding in the audience. It's not easy. They are really hard to identify. So we've been doing a series of tests just to explore what we can actually do with these type of capabilities. And again, we've been exploring on what other platforms we should be looking at. So, obviously CubeSats, we've been talking about here today. As a national mapping agency, should we be helping inform what those sensors could look like, how we can test things out for people? We have real-world applications for these type of capabilities. Again, we've got the new spaceport. We can actually get access to space in a much easier way to test things out. And the other things we've been exploring is things like high-altitude pseudo-satellite use cases, particularly with the sensor that we've been evolving with Australia as well. So hopefully this gives you a flavour and a quick run-through, and hopefully keeps us back on time, as to what a national mapping agency is using. And I think the key thing that I would suggest to people within the audience as well is that, if you need to explore use cases and test things out, don't ever be frightened to approach someone like a national mapping agency, because we have real-world needs. We need to understand the land using space assets. So please feel free to reach out to me or to my colleague Jason if you'd like to explore any of those avenues. Okay, so thank you very much.
Thank you very much, Donna. It always amazes me, the projects that, when I speak to you, the things you get involved in, like peatlands and supply chains and all this other stuff. It's amazing the breadth of work that you do at Ordnance Survey, so thank you for that. I encourage people to speak to Donna or her colleague during the breaks later. So finally, I'd like to invite Aravind up. Aravind is the founder of TerraWatch Space, which is a strategic advisory and communications firm specialising in Earth observation, satellite data and its applications. So it's based in France, but works across Europe and beyond. And Aravind is also the author of TerraWatch Space newsletter and host of TerraWatch Space podcast. If you aren't signed up to those, I strongly encourage you to sign up. They are incredible resources of information on the Earth observation sector, and especially the use cases and the markets that it can work in. So Aravind, I'm sure you'll talk a bit about that now. Thank you very much.
Thank you, Andy. Thank you for that introduction. I feel a bit flattered, but if you sign up, that's great. It's great to follow Nick and Donna. I hope I be a good follow-up to them. So I'm going to talk about a few trends in Earth observation and kind of give you a big picture of what's going on. And that's kind of what I have on the agenda. Hopefully we can get it in 10 minutes. So quickly about TerraWatch Space. So what I focus on at TerraWatch Space is, if you look at technology as 3 A's, the availability, awareness, and adoption, I guess ESA and Ordnance Survey are working a lot on the availability of data, and what I focus on TerraWatch Space is to talk about it to the end users. So you make, you talk to the end users and let them know what the technology can do, in our case, Earth observation, and help them adopt it. So I work with, large corporates or just basically any company outside the bubble that we sit in, and help them develop an adoption strategy for geospatial and Earth observation. So that's kind of what I do, and the efforts on the blog and the podcast are a function of that to talk about what's going on in the industry. So let's talk about the Earth observation stack. I did almost a new version of that. I couldn't fit that into a slide. So this one has some problems in it, which means it's not really the most up-to-date version, but it still holds. So to start with the stack, obviously, it's pretty logical. You start with the data layer, which is where, you generate all the data that's coming from space or HAPS or drones. In this case, it's focused very much on the satellite sector. So of course, you're launching, sensors, hundreds of satellites with variety of sensors into space. And then you have the infrastructure layer, which takes care of storing the data, enabling the compute and the processing. And you have the platform layer, which kind of aggregates and curates all the types of data into one place. Then you follow that up with the analytics layer. So I differentiate analytics, insights, and applications in a simple way. Analytics is basically converting the raw data into something more useful. That's a tree, that's a building, but then that doesn't really serve any purpose. Insights is basically converting those analytics into something more contextual, into something more useful. And applications is where people can go and almost, buy the service with their credit card. So it's the closest to the SaaS model that we speak of, the software, in the software industry. And I come from the software industry before I jumped onto space. So that's a layer that I'm very, very interested in, and that's kind of where the adoption happens the highest, because the barriers to adoption are very, very low for the end users. And to look at the acquisition layer, of course, we have a variety of companies launching a variety of sensors, and this is only the satellites, and every day this changes as new technologies come in, and as ESA and organizations around the world support the creation of new technologies. The logos keep adding on there, but I don't think I need to explain what each of those technologies mean. But the bottom line is we are generating more data than ever before, perhaps in the history of humanity, about the planet, the state of the planet, and also how our activities are affecting it. So obviously, a lot of satellites being launched, and of course, you can't not include the satellites from ESA and other space agencies around the world, which also complement and in some cases help the commercial sector calibrate their data. Of course, you're aware of most of these satellites out there. And going on to the platform layer, the platform layer is pretty interesting because you kind of need to store data in an efficient way, which is what the fundamental infrastructure layer takes care of. But you also need to aggregate it in a smart way, and that's where the marketplaces come in. They help the companies that are generating the data to distribute that data to whoever wants to use in the end user segment. And then you have what I call the platforms. The platforms are where you can go and interact, use different sources of data to plug in, create applications. So it's a lot more interactive, right? So obviously there are a lot of players in that segment, and as we look at generating more data, the projects that are there here will help create more data. These layers are what would enable the distribution of that, and to create value out of it. And one trend that has been happening, of course, you can create as much data as you want, but then if there is no logic behind the creation of data, the adoption becomes harder. So what's happening in the market is also what I call a trend called verticalization. So companies that are focusing on the creation of data for a specific segment, for a specific audience. So if you look at agriculture, you look at climate, or you look at sustainability, wildfire monitoring, you see all of these companies come up, and Earth observation technology is kind of crazy in that way because you can do a lot with it, but it's confusing for the end user because your website looks like you can serve everybody. So some companies try to verticalize, and that's a trend that's been happening, and we're seeing that more and more. Of course, that doesn't stop the fundamental, the base layer from existing. The base layer are companies that still serve a variety of markets. So you can still be multi-purpose because by definition, remote sensing data is multi-purpose and used for use across different use cases. Of course, a developing trend is, the development of a commercial sector for climate based on Earth observation data, and some use cases. This is not the exhaustive list of use cases that are there, but some that are getting a lot of importance and prominence these days. Starting from weather and climate risk, helping companies adopt to climate change, start reporting their climate risks. The regulations are starting to come in, so companies are becoming more interested. Likewise with insurance, you see the development of parametric insurance models, which are primarily enabled by Earth observation data, multimodal Earth observation data, so to say, not just satellites, but also drones and in-situ sensors, energy, carbon, the voluntary carbon markets, of course, as we have seen the development of that in utilities. Those companies which have historically used remote sensing data on and off are now starting to look at it more strategically. Of course, like I mentioned, the reporting use cases and emissions, of course, you can't really do that without satellites, especially in a scalable way as corporations and governments want to do that, right? So even for governments to kind of monitor the tracking of Paris Agreement, it's basically Earth observation data that's going to play a role, and several companies are coming up. The logos that you see there are not exhaustive, so if you don't see a logo, it's fine. It's a representation of companies from a global perspective. What I also want to talk about is weather, because I always feel like it's almost the forgotten child or the sister or brother in the remote sensing world, because it's fundamentally, scientifically, is the same. The weather value chain kind of resembles the remote sensing imaging value chain, if I may. Starting with the observations, again, from satellites, but not only, as I'll show in the next slide. And then you combine all that data into models, numerical weather prediction models, and then you create products with it. So products is essentially temperature, humidity, winds, things that we are used to seeing on our mobile phones, and then insights, basically converting all of that into things that companies can understand. If there's a wind from the northeast at 200 kilometers per hour, should I take care of my power line, or can I still operate my train, things like that. So that's the insights bit. Of course, this is a combination of a public sector and a private sector initiative. It's not just the private sector, although the private sector is coming into more prominence, and I know that there are at least a couple of projects in UFO that are focusing on weather, which is great because there is a big weather gap. I'm not going into the need of the market or the potential of the market, but what's a fact is, there are a lot of data gaps around the world for a variety of weather variables. So we still have gaps to solve depending on which part of the world you're looking at. So yeah, so obviously there's prominent trace of private companies coming into this sector. So that's again something that I want to add on. It's not just about the imaging world, and obviously weather. I think it's almost a system approach, right? So it's not just, and it's similar to imaging as well. You can't just have satellites and fill all the gaps. You kind of need to have a global system of system, and I think ECMWF and EUMETSAT call it the Earth system approach. So essentially covering geo, polar orbit, LEO, upper air using HAPS. Again, I think a couple of projects here, but also in situ sensors and in ocean. So it's a combination of different sensors that help fill the weather data gap. And yeah, there are quite a few technologies that are up and coming. I think Nick talked about Aeolus. It's one of my favorite missions, especially because of its history, but also its capabilities. And you never know what a scientific demonstration can do, because that satellite was not supposed to be integrated into operational weather forecasts into our mobile phones on a daily basis, but it's doing it. So that's the point of investing in the scientific demonstration satellites, and investing in projects like what we're going to hear about today. I want to end with doing not very good this time, but I'm going to end with 5 trends and what I also believe are challenges in Earth observation. It's time up, but I'm going to take extra 2 minutes, if that's okay. So the 5 trends, but I also believe those are challenges. So the first one is sovereignty in Earth observation. I think Nick touched on the point that every country is looking at security, and so sovereign Earth observation is becoming a thing, which means every country, most of the countries around the world are looking at capabilities. They want to invest in their own capabilities. Of course, leverage on partnerships, but they also want to have their own capabilities. And you see a lot of these countries either investing in satellites, acquisition of satellites, or new business models like Albania, which has a satellite as a service model with Satellogic. So that's changing, and that's something to be mindful of as we look at new developments. The second is the emergence of as-a-service models, so space as a service or satellite as a service models. And as that comes in, I believe that there's going to be new commercial opportunities, right? Like companies are going to want to develop just payloads. They don't want to develop their own satellites because they can outsource that to somebody. So what that opens up the kind of market opportunity for HAPS and drones to enable the demonstration of these sensors, because these sensors are going to have to go and fly in space. So there's going to be a market opportunity for testing these sensors in whatever platforms they are, whether it's in HAPS or drones. So that's going to be a new opportunity that's coming in. And companies that are developing these sensors, the third one being, do they go forward and kind of also become a software company and process the data and become a software company? Or are we going to see corporates coming in and investing in the space technologies themselves. So, backward, forward, vertical integration is going to become a thing. Evolution of go-to-market strategies. So, as I mentioned before, it's a very multimodal, multi-source, multi-sensor system. So there's going to be a lot of partnerships and integrations that are going to happen. And that's a challenge that we still need to figure out. And the last one is commercial monitoring for climate. Obviously this has been in the realms of the governmental agencies, the public sector, but in the private sector has started to contribute, in a larger way than ever before, whether it's for monitoring weather or for emissions or for carbon accounting. So, there's a lot of, ongoing trends, but what I marked as challenges are also opportunities for us to kind of invest in, and we look at a lot of projects here, we're going to hear from them, and I think all of them are going to play a role in the future of Earth observation. Yeah, that's about it from my side. Thank you very much for the attention.
Don't go anywhere, Aravind, because I'm going to invite yourself and Donna and Nick to come and take a seat on the stage, please, and we're going to have a short Q&A, so if you can make your way up, that would be brilliant. Thank you very much. Go all the way along and I'll sit here. So, hello, is this, yes, good. Right, brilliant. So, thank you very much, all three of you, for those wonderful presentations you just gave. In the UFO project, we talked a lot about collaboration. Luca mentioned at the start, and all the projects are collaborative. So I want to just open the conversation just by asking about the importance of collaboration within your organisation and between organisations you work with, especially when we're talking about these big challenges we have around climate and so forth going forward. So, Donna, perhaps I can go to you first.
Yeah, no, sure. So I think the key thing for me about collaboration is we don't have time. That we know the climate challenge is running really fast, and historically, it would normally take a long time to develop something. People could do it in silos, independently, etc. We just don't have that anymore, so we need to collaborate to be really efficient and effective in moving forward quickly. And from that point of view, you would imagine that an entity like Ordnance Survey, we've been around for a long time, we're big, really hard to move machinery. But actually, we've been really working hard on how do we collaborate with partners really effectively. So we've been doing work with CGI on their UN project called SEEDS, which is looking at the sustainable use of environmental data. And actually, doing that collaboratively with a corporate entity makes it really easy for us to do really quick evaluation pieces and research, and then decide whether or not that's got any commercial application or real-world application. Again, looking at some of the other things we do as well, we're trying to work collaboratively, and we'll talk about the supply chain data partnership later, but that's bringing a lot of big corporates together to try and solve really critical problems. And I think that's the way we need to move forward.
Great, thank you. So we don't have enough time, but collaboration is the way we're going to overcome it, I guess.
Absolutely.
Yeah. Aravind.
From our perspective, obviously I work with a lot of Earth observation companies on their go-to-market strategies and their partnerships, and it's, they have come to the realization that, they have a role to play, but then they need to also collaborate either with the public sector or with other companies. Obviously, from an Earth observation point of view, it's as simple as, if you're launching a sensor, you kind of need to collaborate with another sensor company or a downstream company that is going to help calibrate the data or process the data. So the collaboration is almost inevitable, because the value of the sector can only be realized, at least from my perspective, if all the technologies kind of work together. From a technological point of view, you can't just do everything with optical, because if you have the clouds, which you do have in this part of the world quite a lot, you kind of need to work together with an active sensor. And it's the case with even if you're looking at a go-to-market partnership, or you're looking at developing the technology together. So you kind of need to get together with the space agency and see what they have in the technology roadmap, so that the public sector, the private sector, can then get an idea of how to develop the technology in a complementary way to what the space agency has in their roadmap. So I think, I've worked on projects before, and it's almost becoming inevitable, and, the siloed approach that was there perhaps in the past is not the case anymore, because both scientifically and commercially it won't work. So, the collaboration is the way to go.
Thank you, Aravind. I think that piece around the market end users you know, they're the ones who know the problem, but we as the Earth observation or the HAPS or the drone community maybe don't understand it exactly like they do. So having that collaboration is so vital, isn't it? Nick?
Oh, no, absolutely. I second that. I mean, build something that somebody actually wants. And the only way you find that out is by going and talking to them and collaborating with them and co-evolving it with them. There's always a great temptation to build something which you think is excellent, and then go and offer it and try and find somebody who wants it, and that's too late by that time. Because if you've misjudged that, then your great technology will fail. And the other way is this kind of lateral collaboration. We're increasingly integrating together multiple elements of technology together into complicated systems which serve complicated needs, and you have to collaborate with this. It's very hard to get your arms around the entire technology portfolio that you need in order to solve a customer problem or a user problem here. So you have to collaborate across in order to do this. And I have to say that in the European business culture and the European academic culture, we are very good at this. If you compare us, for example, to the American business culture, they're not. They try to find one company or one research group who can do everything, and they pile it all up in one place. We work in a much more distributed fashion in Europe. We always have. And I think that's a great strength. It gives us great resilience and great flexibility in solving these kind of problems.
That's a fantastic point, actually, and I guess it's projects like this that help bring that collaboration together as well, isn't it? I mean, touched on it a bit there as well, but the barriers, there must be some barriers in terms of developing the HAPS or the Earth observation capabilities from small satellites and also drones. What do you see the barriers to really innovating in this area are, and how might we overcome them going forward? Who'd like to take that one first?
Yeah, I guess the barrier, I can think of two. One from both ends of the value chain. One from the end user point of view, you know, what should we innovate for is perhaps unknown. I think, you know, a lot of times the innovation or the investment happens from a technological point of view, but then, you know, obviously what that results in, you know, is a question mark, and, you know, it's almost a, you know, push all the time without resulting in a pull. So how can you make that happen? That's perhaps a big barrier, and you know, I work with several startups, and that's kind of what is a big challenge, that adoption gap, as I talked about. And the second one is more, you know, from, I guess, I don't know if the space agency agrees or not, but then from when I work with private investors, they don't know what to invest in, because, you know, it's more lack of understanding, well, perhaps on their side, lack of understanding of technology and what the potential of the technology is. So, you know, they don't know where to put the money in, where they're going to get the returns. You know, obviously they care mostly the economic return, you know, whereas the, you know, the space agency or public sector looks at more strategic, societal, environmental. But then from their point of view, it's more economic. And, you know, given that they're going to kind of help the companies scale up, it's important that, you know, that barrier is also addressed.
Interesting. How do we convince the investors? How do we convince the investors it's a good tech to invest in?
How do we convince the investors? Yeah. Well, I guess, yeah, for the investors and the customers, I've realized that there's only one metric both of them care about. It's the numbers, and you kind of need to show the numbers. And for customers, it's what I found that works better is, for customers, it's opportunity cost. I think it might work with investors as well. If you don't invest in this technology today, this is kind of what you're going to lose out in the next 5 years. You're not going to be able to monitor those assets, or, you know, save that kind of money, or, you know, have operational efficiencies. And I think that kind of the same works with investors as well, because they need to understand that they're just not investing in a technology for the sake of it, and it's not just, you know, one of those, you know, high risk investments that they're doing. It's actually something with potential, and I think that they need to be convinced, and, you know, some metric in the sense of opportunity cost could help. It's kind of what I found, and, you know, so far it's been kind of working.
Thank you.
Yeah, we shouldn't forget that investors invest in people too. The people component is really important. That actually you've got to be credible, you've got to know your markets, you've got to really understand your use cases, and I think that's a really key element, actually, that, you know, you've got to find that absolute market pull, because if you're just pushing technology, you're not going to make the commercial value. So that's one key thing. But I think one of the major barriers we face is actually language. We forget that these people don't understand what we're talking about. You know, they assume they've got to have PhDs in, you know, astrophysics, or they've got to really understand sensor development. So we've got to be really careful about the language we use to enable them to interpret the value to them. So to me, that's one of the biggest barriers I think we face in our industry, is how do we interpret it appropriately for people to buy into it.
Absolutely true, and I'd hardly mention space if I can avoid it, because it gets that immediate, oh, it's about astronauts and Mars, and it's like, no, it's about farming, you know. But to pick up on what Erwin was saying here about investability, I've got to do an Appleton Space Conference later this week, so I'll give you a spoiler for what I'm going to say there. The traditional culture of the space industry is very risk averse, which means it takes a long time and it's very expensive. It takes 10, 15 years even to get anything into orbit before you even start to think about exploiting that. That's not investable. It's too long. However, what has happened in the last 5, 10 years is that timescale has shortened enormously because of the costs coming down and because of more acceptance of risk. So now the time to get something in orbit is maybe 5 years. That's investable, right? So now the private investors are coming in because they can see a path towards the return that they're going to get at the other end of that. So we're already overcoming that major barrier towards having a commercial system, and we've got to continue in that direction. We've got to make things, give the investors confidence that they can see a path towards when they're going to get their money back.
Yeah, that's a great point. I think when it's applications that don't actually need a new satellite, we can even reduce that even further.
Which is why the applications stuff went commercial first, because it's quicker and cheaper to commercialize.
We've only got a minute or so left. Do we have any questions from the audience? Yes, there you go. Thank you.
Thank you. You talk about a lot of technologies to observe Earth, and I would like to know if you already have metrics about how your data can be hacked up to change and for instance, help us with the climate change and things like that. I mean, you observe things, but how do you know if the data you get have value and can be hacked up to let's say, for instance, know if we can build things to prevent the flow to go inside lands and things like that.
I'd like to take that one.
Okay, so we do monitor change, obviously, on the land. That's one of our key jobs as a national mapping agency. And historically, we've just done that in snaps of periods of time. So in the UK, we do 3-year update programs. But actually, going to your point, you know, actually, we need to make that monitoring much more effective, because particularly in terms of some of the green financing initiatives, they want to be able to monitor really accurately that their investments are going in the right way. And actually, that's one of the things that we're looking at doing from involving the Supply Chain Data Partnership, which is a collaboration between ourselves, Unilever, Deloitte, Esri, Planet, to understand how location is fundamental to that point, because we need to know where things are. Believe it or not, people don't know where things are. It's a massive global problem. But then how do we do the monitoring effectively for that? But if we don't know where things are, we can't do any of that. So we're starting with that initial point, and then we can enable people to do the monitoring really effectively to understand that change that's going on, because they all have different requirements for their different use cases. So, so it's not specifically answering your question in terms of what those metrics should be, but you know, we are on that journey to deliver that.
Maybe one thing I'll add is, because I work a lot with the end users, what they are almost surprised by is our tendency to focus too much on the remote sensing part, and they want to know, you know, if there's a company who's, you know, operating a lawnmower, for instance, they want to know if the sensors that they can install on the lawnmower can calibrate and complement what data from drones or HAPS or satellites can do, because the calibration part is almost unknown. And you know, if you look at utilities, for instance, they're used to sending people around to check if there's a leak or if there's, you know, construction activity going on or not. And now we're suddenly saying that we're going to replace that I mean, to be honest, we're not going to completely replace that because we still need those people on the ground to do the calibration, you know, to have those metrics. So the adoption needs to happen almost, and I think that's where the boring stuff that I talk about come in, change management, because, you know, they can't do this monitoring change effectively that, you know, you can switch off everything that you're doing and, you know, change to remote satellite-based or drone-based monitoring in the next minute. So that's again a part that, you know, adds into the, it's about how the adoption happens and, you know, how the requirement from the users, you know, kind of also enable the development of the technology, because the technology can, you know, of course it's an objective truth, it's going to measure and going to give the, you know, the numbers, but how those numbers are used and the impact that it has for the users also need to be, you know, kept in check. And I think that comes from, you know, things that you were talking about.
Great. Well, thank you very much for that question. I'm going to draw it to a close now, just because we're overrunning, and apologies for that again. We will give you half an hour break. Please come back at 10:02. That'll be great. We'll start with the pitches then. And can I ask all the people who are pitching in the first session to come and sit on the front row, please? So we got you swiftly up to do your pitches. So it just leaves me to thank the three speakers. I think it's been wonderful to listen to what you've got to say. So I thank you for your time, and I encourage everyone in the audience to go and network with these folks and talk about the projects they're working on. And yeah, that's the call for today: network and collaborate. So thank you very much again to all the speakers this morning. Coffee and everything is just again. So welcome back to what I'm going to call the meat of the session. Why we're all here today is to give all the projects a chance to pitch their work that they've been undertaking over the past 18 months or so. And we're going to make this a bit interactive as well, which is great. So if you want to get your phones out and scan the QR code, or go to the website here, menti.com, and type in the Menti code, you will get access to the scoring for every single participant. And there's actually a prize that we're going to award at the end of today as well for the best pitches and the best projects, which is going to be awarded by ESA, which is absolutely fantastic. So as each participant, as each project speaks, we'll ask you to rate them on a scale of 1 to 10, with the scoring based on the potential of each project to make a real difference in addressing specific societal challenges. So yes, please do this after each pitch, and we'll collate all the scores at the end. We're also going to have scores coming in from the panelists we had this morning, the excellent panelists, who will also be rating the projects, and we'll combine the scores at the end in some sort of crazy European style music competition, and come up with a winner at the end. So that's it. Now each each project will get 4 minutes only to pitch their idea. We will be quite strict, so Luca and I will be holding up a 1 minute to go sign as they get close to the end, and we'll come and drag you off the stage if we have to. Hopefully that won't happen. It's not happened yet, and I'm sure all you great projects will keep to time. And that will mean we can get to lunch on time as well. So if you overrun, it's all your fault that we don't get to lunch. Okay, so we're going to have a facilitator for each session, and I'd like to welcome up now Paula Comanescu from Cluj IT, one of our partners, who will be introducing each of the participants in turn. Thank you very much, Paula.
Thank you very much, Andy. Thank you. Welcome, everybody. It's a pleasure to see all of you here. I am Paula Comanescu. I am representing Cluj IT cluster from Romania. We are an IT cluster that, of course, we started regionally. Now we are nationally and internationally due to projects such as UFO, and we are proudly part of the consortium implementing the UFO project. And I'm honored today to present the pitching session. So without further ado, allow me to invite to the stage from the project 5 Dark Age, Mr. Pavlos Hadjigrigoriou from Heritage Management E-Society, Hermes, Greece. Please.
Thank you very much. Thank you for spelling my last name fluently. Thank you. So I think in the history of the Eurovision, the first song never won the awards, but somebody has to break the ice. We are the 5D Arcade project, 5 dimensions architectural aid project, which focuses mainly in heritage buildings, in historic buildings. Buildings are getting old, buildings are getting older, especially in Europe, but worldwide. And as they get old, they face the same challenge. The challenge is how to avoid the deterioration, how to avoid collapsing, and how to avoid also the getting lost in oblivion. Okay. Yeah, I don't need that, but okay. So, as a Hermes NGO, we are a small NGO company, and we are doing for more than 10 years documentation, door-to-door, building by building, historic buildings everywhere, not only in Greece. And of course, the final outcome of this idea is giving the municipalities and the local communities a conservation plan and useful digital tools in order to preserve and protect the cultural heritage. All these actions led us in 2015 in a Europa Nostra, a very famous award of the European Union for Cultural Heritage. But going door to door, building by building, it's time consuming, and because time is money, it's very expensive. So we thought that there should be a better way to create a conservation plan with IT and digital tools. So this way we create a consortium using 2 excellent companies, IT companies, JGC and GetMap from Greece, and also integrating a Romania NGO, the Association for Monuments. They are well known for their project Ambulance for Monuments. So you can see there is a connection here. We document and they have the ambulance. This consortium started a project in Syros, in Cyclades, which is called 5 Dimensions. 5 Dimensions, why? First dimension is what we do, the documentation door-to-door in the research. Second dimension is a web GIS map. And the third dimension is a 3D model, a very accurate 3D model with the help of UAVs mainly. The fourth dimension is intangible heritage, which is very important for a digital twin in our opinion. And the fifth dimension is the conservation plan. So we have these 5 dimensions, and in the end, we have what we call a holistic digital twin of the medieval settlement of Anno Syros, our case study. But that wasn't the purpose and the final step of the project. The idea is how to save for us time and money and go directly to the conservation plan without having to go door to door to every building. So we took all these data sets and we compared them, and we saw that from digital twin, we can have more than 90% accuracy in the conservation status of the buildings, which is much more than we hoped at the beginning. That means that we can massively Earth scan settlements and cities everywhere and then create conservation plans that are very helpful, first of all, for the local communities and the municipalities, because they can prepare themselves for the protection, the preservation of the cultural heritage, but also for the government, because we have major hazards, like an example, earthquakes or floods due to climate change, that can put a risk to these buildings. Finally, and this is my last comment, at the end, with the help of our end-user partners, the Romanian partners, we saw that there is also another market, the construction market. The construction market can focus on opportunities from these conservation plans and go directly to the owners and ask them to be proactive in the conservation, the restoration, because they don't have to wait now for the owner to find them, but they already know which owners in the future they're going to have needs for this restoration. So we are 5D Arcade. We are very happy to be here. It was a pleasure for all these years. We want to really thank you, the UFO Project, for the trust and the opportunity that they gave us to become part of the UFO Project. Thank you very much. We are in the exhibition area if you have any questions. Thank you.
Thank you, Pavlos. Thank you, 5D Arcade. We will continue our presentations with the project Aid for ESA, and I invite Mr. Michael Striligas from Vertiliner, Greece.
So hello to everyone. My name is Michael Striligas. I'm the founder of Vertiliner, a field robotics company incorporated to develop autonomous drones capable of digitalizing the indoor spaces of building assets and communicate actionable information to multiple stakeholders. We developed the Aid for ESA project aiming to advance our technology offering. To achieve this, we have created a consortium consisting of Vertiliner, which is the leading partner of the project, firm that possesses expertise in IoT sensoring and communication, Crescit, a research center with expertise in embedded system and electronics, and last but not least, Asenko, our end user that is capable to get benefit from the outcomes of this project. Monitoring activities are spanning in all the phases of a building's life cycle, starting from the construction phase, moving to the operational phase, and lasting up to the end-of-life phase of the building. So we are focusing, first of all, on the first phase of constructing the building, which includes a series of highly fragmented and complex processes. The main application that we start working on is referring to the MEP systems. MEP systems is the acronym for Mechanical, Electrical, and Plumbing Systems. So the idea is to be able and remotely monitor the operation of these systems, but in advance to provide the necessary information regarding how these systems are going to fit in these areas. So we have worked with project managers and engineers in more than 25 countries and witnessed firsthand the struggles to get precise data on building assets. So this data should be acquired by humans from hard-to-reach areas and have to be communicated to the suppliers and contractors in different mediums. So the Aid for ESA project is solving this problem with an integrated solution that consists of a custom-made self-flying drone operating in the building, creating the digital twin of the building assets, guaranteeing high precision and safety in the hazardous environment of the project, providing inspection and monitoring services. Here you can see the drone that we have built with the support of the UFO project. The business model that we are using in order to get the benefits of the commercialization is based on the fixed cost of selling the drone and then selling the data for the contractors when they would like to get access to the project. We start by serving the niche market of elevator system, which it's a part of it's one of the verticals of the construction sector, particularly for cities that sustain operation in high-rise buildings. This is something that we can see in the future to happen also in areas out of Earth, in infrastructure that needs to be monitored without any human intervention. As Vertiliner, we get great experience from our collaboration in this international consortium in terms of the knowledge transfer. And in order to scale this solution further, we are seeking for 450,000 euros. So thank you very much for your attention, and I'm inviting you to join this journey of self-flying drones in indoor environments. Thank you very much.
Thank you, Michael. Thank you for keeping the time. We highly appreciate it, and we continue with Project Datum, and I invite James Dunthorne from Neuron UK to the stage. Please.
Thank you. I'm James Dunthorne, co-founder and CEO of Neuron Innovations. And today I'll be talking about Project Datum, which is distributed air traffic unification and management. So the risk of mid-air collisions is what we're trying to solve here. Integrating drones into airspace is a big problem. And we install ground-based IoT sensors and connect them into applications to provide drone pilots with the ability to see and avoid other aircraft users. But deployment of these sensors is expensive and tricky. So we need ways to be able to do this in a scalable manner. So in terms of this project, what we're trying to do here is to develop a flight tracking application and integrate into the drone's mission control, develop a ground-based IoT network of aviation sensors, to develop the regulatory paperwork to actually glue this all together, and to conduct some flight tests with the DroneNow prototype. So this is the partnership between our two organizations. We work with IoT and blockchain, deploying and integrating aviation sensors in this case with a newly developed flight tracking application. And Dronamics are a large drone logistics company with partnering with EasyJet. Their role was developing the regulatory paperwork and building the prototype aircraft to complete the flight testing. So here we can see some of the actual flights that were being undertaken. So as part of the project, we developed further our prototype system, which basically tracks where aircraft are. It takes in inputs from multiple IoT sensors and then feeds that into the ground control station of the pilot. And what we can see here is some of the data that we received from the actual flight testing, where we had the drone being taken off from the airport, doing circuits, and being integrated with the data from other aircraft in the airspace. And being able to see all of this data on a single map is really important to be able to actually digitize air traffic management and to ensure that all aircraft can be seen and avoided. So the solution was taking these aviation sensors, we connect them into the IoT, we took the IoT network devices and then integrated them into a flight tracking application. This was then available on the drone control station, and the pilot was then able to see the aircraft as they were flying and be able to monitor both the drone and the other aircraft in the field of view. In terms of the next steps, we're exploiting the aviation use case through two projects. Firstly, Project Blueprint, which is a £3.6 million project we won. And that's basically going to be creating UAS geographic zones around the UK to be able to integrate aircraft. We're going to be developing other IoT use cases, so EV charging, climate sensing. We're going to be launching a token to incentivize the IoT sensor deployment at scale. And we're currently closing a funding round. Projects like this are great for collaboration and the MVP building. Nothing ever works first time, so testing and testing and testing again is really important. But deployment of IoT sensors requires a scalable model, and community sensor deployment via token incentives is a powerful solution that can help do that. Thanks for listening, and that's Project Datum.
Thank you very much, James, and thank you to the Datum team. We would like to remind you to kindly vote to express your opinion on the project by using menti.com. And I remind the audience that is following us online that they can also vote. The code for voting is 1525 768. That is 1525768. And we will continue with project Drone News. I'm happy to invite Mr. Nick Papaokonomou from Hypertech ESA, Greece. Sorry for that.
Hello everyone, my name is Nick Papaokonomou. I represent Pragma IoT and Hypertech. Together we developed the Drone News platform. The challenges of this project addressed is reaching inaccessible or remote location for new coverage, especially in cases of natural disasters and accidents, in a timely and cost-efficient manner is crucial for good reporting for new agencies. Regarding this, the market of the drone news services can be estimated at 1.5 billion, assuming persuasions of 100 hours of drone news videos per publisher per year, with an average cost of 300 euros per hour of video. Initially focusing on the US market, drone news market size estimated at 150 million. The main of the Drone News project is to provide new agencies and media companies with the ability to source near real-time user-generated videos of remote locations or urgent events such as accidents. And the key innovation of the Drone News is that it enables the cost-efficient crowdsourcing of drone capture videos in real time, along with verification of the uploaded videos, video intelligence, and the automatic removal of sensitive information from the videos. The Drone News will allow two modes of operations. The first one is that the new agency uses Drone News to request on-demand real-time drone footages for a specific event, post-processing, and make it available for content enrichment after verification. And also the new agency will use Drone News as the hosting platform of drone users, aiming to supply the agency with drone footages about incidents that are witnessing and for which there is no news coverage generated yet. The results is that we developed the Drone News platform as an intuitive and user-friendly interface, which allows drone owners and new agencies to register and create their profile in the Drone News platform, to discover and receive notification on requests for footages by the new agencies, to respond to those requests and by providing drone videos, and to get paid upon successful validation of the footage by the requesting new agency. Some next steps are that the consortium is already planning activities to obtain further funding by leveraging opportunities through Europe and national funds, also to run operational service for Media Today as the first client of the system, also engage marketing activities for communication platform to other digital agencies in Greece initially. And depending on the success in the local market, the consortium may steer its efforts to the European market as well, and also sell actual drone news platform licenses. Through this UFO project, we learned a lot working in a strict deadline, and also thank you very much that we have the opportunity to work in a new and rapidly growing field of the drones. Thank you very much.
Thank you, Nick. Unfortunately, the project fair, who was scheduled to be the next one, have just let us know that due to a last-minute change, they cannot be with us. So I kindly ask you in Mentimeter to just give them one, and so that we can skip to the next project. So while Gaia Drone is preparing, I will. Okay, this would have taken some of our time. And I think we are okay. So I invite to the stage Michael Arvanitis from Gaia Rome, Romania.
Hi, good afternoon, everyone. My name is Michael, and I represent the consortium by MDS in France and Gaia Rome in Romania. So our project is called Geodrone. It's actually it's actually a drone robotic system that uses a ground-penetrating radar sensor for critical assets, preventing maintenance. What's the idea behind it? The idea was that we have so many critical infrastructure in Europe that is not really maintained or tested the right way. Either because it's the nature of it is challenging for people to test it, or you test it in a destructive way, which is really bad for the asset itself. So our project is to create something that will be a right solution for nuclear reactors, for dams, for bridges and tunnels, and so on. So we decided to use a ground-penetrating radar sensor, and this sensor gives us data from the concrete surface of these assets. It can give us information about the rebars, the number of rebars, how close they are to each other. We can find any defects inside concrete, like voids. We can see where the water or deterioration is happening, and we can inform the right way the asset managers of what is happening inside their asset. So this is actually helping them to schedule any preventive maintenance they would like to do, and also to avoid any damages to the critical infrastructure they own. Right now, after the really good help from the project, from the UFO funding, we have developed a full working prototype at DRL7. So we created our own drone that flies very close to the surface of the asset. We have demonstrated that outside of the lab. We have an optimized data collection methodology right now. And we have a pricing model. So on the right side, you can see some of the data collected. That's rebar data inside concrete. The next steps are actually to have a commercial product at some point. We expect to have this in about 3 to 6 months from now. So we are going to reach TRL9. We are looking actively or not that actively. It really depends on how you see that for investors. And we are right now in a commercialization phase with focus on the owners of these critical assets. A few pictures of the drone itself and the antenna radar, the radar antenna on the front over there. That's another picture of it. And this is the contact detail of Gaia Rome and MDS, so whatever question you may have, you can contact us. Thank you so much. Thank you, Paula, for everything.
Thank you, Michael. Thank you, Gaia Drone team. I invite to the stage the next project, LEMIP, Yuri Ponzani, Recycle to Trade UK.
Thanks everyone for being here. I'm Yuri Ponzani, the Managing Director of Recycle to Trade. We are an environmental sector specialist. We develop innovative data platform for the clean tech and waste management industries. Today the topic is quite an interesting topic, fugitive emission and landfill site. Probably most of you know that the greenhouse gas emission from landfill sites worldwide account for 10%. So 10% of the greenhouse gas emission are coming from landfill site. So, and what we want to address here, the lack of constant, frequent, and reliable data from landfill site and environmental site in general. The issues with greenhouse gases from landfill site, well, the greenhouse gases from landfill site are a risk and an opportunity. Risk because uncontrolled fugitive emission can lead to fires and explosions. Of course, there's a knock-on effect on climate change, and there are constant regulatory issues in waste compliance for landfill operators. The opportunity, there's a big opportunity, are the revenue generation from gas capture and extraction. So in 2020, the total global market value of methane gas extraction from landfill site account for $3.21 billion. The projection for 2021 is an increase up to $5.21 billion. And the important point is that these days, the competition is monitoring landfill sites in a way that is not spotting the whole issues. Basically, they are not monitoring the whole site. The monitoring solutions are deployed on site are not frequent enough. They provide static data, static information carried out quarterly or yearly based on the environmental permit of the environmental site. Our solution span across all the old site. It's frequent. It's built on remote sensing, satellite data, and near ground site data with drone service, and in the near future, hopefully, ground data via a ground data toolbox. Those are examples of our images and analysis we run. You can see land surface temperature, vegetation indexes, the health of the vegetation around the site, and the real image. And those are the other information. On the bottom left side, there's an analysis run with a drone, integrating a payload with gas, with methane sensors. That's telling you the story, the real story of landfill site. And the problem here that there are lots of benefit actually in integrating or improving the gas collection on site, meaning more revenue for landfill operators. We have to think about the landfill site rely on revenue these days mainly from gas capture. It's not like 30, 40 years ago. So gas capture is really important for them. And there are other benefits, like identify fugitive emission to ensure safe operation and minimize risk for fire explosion, improve regulatory compliance by providing reassurance over fugitive emission, and moreover, improving and enable an efficient maintenance over the site infrastructure, the capping of the site and the membranes. So I think that all those images show you that there's an emergency there and there's an opportunity for landfill operators. And that's really important actually to take advantage of new data stream of information. Yes, thanks a lot for this. Sorry, the news one. If you are more interested, you can come and visit us in the site. Thanks a lot.
Thank you very much, Yuri. And it is important for us to make sure that all projects have the same chances. So thank you. I would like to invite the next project. Remind you to vote on menti.com with code 1525768. And I would like to invite, okay. What happened? Am I too much back? Okay, sorry. One back? One back, please. I think this is it. Okay, sorry for that. Project Mapper, Tristan Freville from Térémis, France.
Hi everyone, I'm representing Tristan, who is ill. Have you ever stumbled on the ground on something? I'm sure you have. And just imagine if what it is for a machine that is constructing a highway, for instance, when it stumbles on some pipes or some very sturdy infrastructure on the ground. it is a catastrophe for the construction project. So the MagMapper project is a new way to understand what's underground using magnetic data. So usually when you use probes, magnetic probes to sense what's underground, you use things very high, and the precision you get is quite low. And also, you have another problem with a flying object used for mapping underground, is that your flying object is producing magnetic noise. So you want to sense something that is completely hidden among the noise of the carrier of your probes. So what we've done in the MagMapper project is to use new noise compensation theory in order to cancel the noise of the carrier. And we have several different kind of drones, and you can see the ones on the left that are used as a fleet, which is then able to map a very large portion of the field in a very short time. And also, thanks to the UFO project, we are able to use multiple sensors on the platform and to move the platform very low, such that the resolution is very good. And the solution is quite efficient, and we achieve a 3 times cost efficiency compared to other methods. And so it's used for a lot of use cases. So one of the very interesting one is preventive archaeology. So we are able to map what's underground and the archaeological artifacts, which is quite very nice when you work in that field. It's a very something that we like to do a lot. But others are very interesting too, especially using finding where landmines are to prevent explosions. So the idea is to sell the material, but also to sell the data. That's the business plan. And so what we've learned, we've achieved quite a breakthrough at the end of the project, because now we are able to map magnetic data as a vector field, which is quite something that's new. Nobody's done that before because precision was not enough. And it's kind of something that we didn't expect from the project, but it's quite nice because we used sensor arrays, and we were able to use that sensor array to calibrate everything nicely. Thank you very much.
Thank you to the project MagMapper. We were scheduled to continue with the project Q-level demo, but unfortunately due to a flight delay, they will arrive a bit later, so we are skipping them, and we are moving to the last pitching of the first session. The good news is that we are getting our lunch break in time, so if you allow me to just go over the Q-level demo presentation, and I ask you to click on not available or one in the Mentimeter. Sorry. And I invite the project Vine Signal, Ms. Shushma Shankar from Dit Planet AI UK. Please.
Hi everyone, it's nice to be here. I'm Sushma, I'm the co-founder of Deep Planet. We're a UK-based company, and we are building the ultimate climate tech solution for agriculture, and we're starting with the wine industry. I'll talk a little bit about the problem, our solution, and more specifically on the scope of the UFO project itself. it's a little less known fact that wine grapes is one of the largest, second largest agricultural market at over $420 billion and is set to double by 2030. It's also known that wine is said to be the canary in the coal mine for climate change, which basically means that the crop has been seriously affected with the changing weather conditions. Harvest has been pulled or pushed by a couple of weeks to a month, and yield has become unpredictable. Inputs have become expensive in terms of irrigation, nutrition, and diseases, and basically vineyard management has become impossible. And so if nothing is done to mitigate these risks, 75% of the world's vineyards will be gone by 2050. And so what we've done so far, we are working with a number of customers and some of the large wine companies, saving them millions of dollars. And we think we are at the cutting edge of how to transform this industry. And we're doing this globally using satellite imagery, machine learning, and painstakingly collected ground data around the world, along with a team that's come out of the University of Oxford. So within the UFO project, we partnered with 100 Hills, a very beautiful vineyard in Oxford, if you do get a chance to visit. It's about 20 hectares, and their main focus has been on how to improve on their sustainability score. Mainly, they want to improve on the quality of the grapes being produced, but also on the carbon footprint and how to measure it, how to assess what they're doing right now, and how to adapt to the changing conditions. So some of the key objectives of the project that came out of a lot of discussions with the growers was to understand nutrients in the soil, understand what's the nitrogen, potassium, magnesium levels, not just monitor it, but how do we translate that into actions. And the second part of it has become very interesting, which is monitoring the soil organic carbon, or baselining how these carbon elements is spatially distributed across the vineyard, and also how has the vineyard changed across for the past 5 years, and what actions can be taken in terms of regenerative agriculture to improve this. And also some of the main focus has been how do we translate, again, I repeated, sorry, but how do we translate these into actions, and how do we provide a user-friendly interface that can be interpreted. So the solution that we came up with was using satellite imagery, both the European Space Agency, planet satellites, a lot of ground data that we collected with their vineyard team, which basically included a lot of soil samples across the growing season, as well as taking tissue samples and correlating all of this data with the satellite data. And we've been able to produce spatial maps as well as actions based off of that. Going a bit further, what have we achieved with this project, which basically we've been able to monitor these nutrients, but what has been interesting is a lot of interest that's come outside of the wine sector in just monitoring carbon and nutrients and kind of providing this horizontal solution to a number of these partners. And we've continued to work with 100 Hills, our existing partner, in developing, understanding the biomass in the vineyards and assessing carbon in the biomass. So in summary, we've had significant market traction in this sector, but very interested in building out the full solution for the wine sector. Our ask really here is, if anybody has any connections with the wine industry, we'd love to connect with you. We're raising our seed round, but we're also interested in some of the grants which we have in the pipeline, and we'd love to connect. So I'm out here. Feel free to come and chat. Thank you.
Brilliant. And as if by magic, we're back on time, which is wonderful. What an amazing variety of projects we just heard from then. People operating drones and making that safer, through to looking at landfills, and personally my favourite, not being biased here because I was helping to monitor the project, but wine and Vine Signal, what a fantastic project. Vote 10. So please, the opportunity now is to go and network and speak to these people who've just presented. So they'll be around in the networking area. Many of them have stands, so you go and talk to them there. There's also one-to-one meetings. If you scheduled a one-to-one meeting, they're happening in this room, actually. So do come back here for those one-to-ones. Lunch will obviously be served in the same area where we've been networking already today. Can I just ask you to give one more big round of applause to all the speakers who have presented this morning? And finally, can I ask all the people involved in the actual UFO coordination, so the Cluj-RT and KTN and all the others, to stay behind, because we're going to have a quick picture with everyone while everyone else gets to go and grab all the lunch. Thank you very much. Oh. Back at 2:10, sorry. Okay.
Welcome back, everyone. Welcome back on the main auditorium. I hope you had a nice break. I see many of you connecting, networking, talking. It's really nice to see this energy, and it is exactly what we wanted to see out of these days. And I hope that some of the conversation will continue after today as well. Now we're going to start in a few minutes with the second batch of pitching. A few more projects left to go. The same rule apply from before. We're going to, if you can go to menti.com or scan the QR code and use the Menti code 4489882. This is different from the one this morning, so make sure that you get this one right. And then as the pitches, as the people will start pitching, you will be able to vote. Please rate the potential of each project to make a real difference in addressing specific societal challenges. Now, I'll leave it with Jonathan Williams from MSc. He will introduce all the startups and enjoy the pitch.
Thank you very much, Luca, and good afternoon, everyone. My name is Jonathan Williams. I lead a company called MSc International. And we focus on the blue economy. We make collaborations happen across that maritime domain. So it's a great pleasure to be able to introduce the 13 projects from the UFO Project this afternoon, which are generally focused on maritime, environment, and climate. So I'm not going to waste any more time. And we'll get straight on to the first project, which is, I'm delighted to introduce a project which is looking at forestry. We don't need, everyone in this room is totally aware of the role that forests have to play in our environment. So allow me to introduce the 4F project, headed up from Bulgaria. Rositsa, over to you.
Thanks a lot. Ladies and gentlemen, dear colleagues, it's my pleasure to present our project 4F to you. 4F means Flying Forest Fires Fighting. What is the idea? The challenges that inspire us to make such a proposal to UFO Project and to develop such an innovative technology was taken from the fact that 10% of CO2 emitted worldwide is due to the forest fires. So by aiming to reduce the CO2 emission worldwide, we really could do a lot of things for our life. Furthermore, the existing technologies taken that are implementing thermal cameras, they need direct line of sight between the camera and the region we are going to scan for a forest fires. The thermal cameras are more useful when we detect a fire, not so useful when we have to prevent from the fire. So our solution, our goal is to look for flexible, not so expensive solution that could allow us to have a vast deployment and easy collection of data to prevent from forest fires. And we are working with fire brigades in Bulgaria, and they said, if you warn us well in advance, we could do a lot of things in a much better way. So that was our inspiration. Then what we have done? We have done 3 things. First thing we have done was the sensor. We developed a sensor. You could see it upstairs. And this sensor measures the moisture and dead float temperature and the moisture and temperature of the soil in the forest. So we deploy sensors in the forest or in a high mountain. Then we developed a gateway. Our gateway is flying over the region of interest where we deploy the sensors. So the sensors, they are sleeping, but every 4 seconds they wake up, and when our drone is flying above them, we collect data. We collect data, historical data, we collect current data, and also we collect estimated of the forest fire risk index, which is Chandler index, in fact. So the data are directly transmitted to the communication server. This is our third part developed. And on the platform, we could map and raise alarms directly to the authorities responsible for the forest fire detection, but also forest fire prevention. So we are more focused on prevention rather than on detection. This is the architecture of our platform. We have sensor deployment, communication part on a drone with gateway on a drone, and then communication server processing the data. What we achieved so far? We are now having a prototype working at TRL 7. We are looking for a smart investor to go and to develop further the technology at TRL 9. We have a potential clients as public authorities for civil protection, private forest owners, but also commercial companies, European national level agency performing environmental studies. We are very thankful to UFO Project for the opportunity to develop the innovative solution and to present it to you. we are two companies collaborating on this, Comicon and BM2. And that's all. Thank you very much for your attention.
Okay, from land to sea. One of the real challenges of our oceans is illegal, unreported and unlicensed fishing, depleting the fisheries resources of many countries, particularly in Africa. So it's a great pleasure to have the ALMA project, led by Cambridge Sensoris in the UK, who's working on solutions to address that problem. Steve, over to you.
Fantastic. Hi, my name is Steve Clark. I'm the founder of Cambridge Sensoris. We're based in Cambridge, in the UK. And I put a lot of words on the screen, but you were pleased to hear I'm not going to read them all. We have designed a system through the course of Project ALMA that allows the effectiveness of survey vessels to be greatly extended through the use of drone technology. But using drones on moving vessels is not a new thing, but having them take off and land autonomously without the oversight of a skilled pilot is hard. And having skilled pilots, drone pilots, permanently deployed on offshore vessels is expensive, and it's difficult to find people to do it, which limits the rollout of drones for surveying large areas of the sea, in this case for illegal fishing or monitoring of maritime borders, and there are other applications as well. So in this consortium we worked ourselves. We're a radar company. We make micro radar. Radar is an excellent technology for seeing long range in all weather conditions. We worked with a flight controller manufacturer in the UK called Canon Lens, and we worked with Bayer Consult in Romania to support market uptake and use cases. And to cut to the chase, what we were able to do was create a radar system on a drone that allows you to pick up the deck of a ship and locate it relative to the drone in all weather from hundreds of meters away. This means that you can land the drone knows where the deck is reliably, repeatably. It works without GNSS coverage, and it reduces the need for skilled pilots and eventually will remove them altogether. It's difficult to convey how this works, so I suggest you come and see it. We've got it on our stand in the map room. We've got a demonstration kit. Through the course of ALMA, we have designed this radar-to-radar communication capability. It's novel. We've applied for a patent. We're making them and we're selling them. So as a small business owner, that's the asset test. If you can make something that people want to buy, then you've done something at least half right. Please come and visit us, and I'll tell you and show you on the stand. Thank you.
Thank you, Steve. Okay, monitoring biodiversity, a real challenge on land and the sea. But we now have the BIOG project, led from the UK, IM Geospatial, which is a feasibility project looking at monitoring biodiversity of grasslands. Over to you, Alexi.
Hi everyone, I'm Alexis Smith, and I'm going to talk to you about the language of biodiversity. Before I start, thank you so much to UFO, to the KTN, and also to this amazing institution, the RGS. So why is biodiversity important? From ecosystem-based approaches to climate or even nature-based solutions to climate, health issues, food, even water security and sustainability for livelihoods, Biodiversity is the foundation upon which we can all build back better. So what did we do in this project? The key aim here was, is it possible to measure biodiversity in a validated, verified methodology delivered at value? We did a whole load of stuff with Earth observation data, and then we basically went out and found some areas and flew some drones. We got some data together. We looked at radar data. We found out that wasn't probably going to work within this budget and how we would do this project. We looked at standard AI feature extraction. It's a big problem, trying to identify features and extract them and bring them together. It wasn't going to work. So in that instance, what do you do? Use the Duckworth-Lewis method from cricket. You also read up loads of different papers around language, signal processing, language metrics, all sorts of really interesting information. This guy, Dr. Arik, I can't pronounce his last name, so I'm not going to try, at University of Cambridge, he's developed this amazing idea, which is you can understand if animals speak in an intelligent way by not understanding the language, but by understanding or measuring the length of each sound and the frequency that sound is being used. So we use a lot of ats and thes and buts, but we don't use a lot of, I don't know, philosophy or big long words. He also does stuff with these critters, which I quite like. What did that mean? So we took that information and we turned that idea, which is we don't need to measure and understand features. What we can actually do is just measure the different differences. And then if those geeks are out there, you look at the second derivative of that stuff and you use a lot of ensemble modeling and you use a lot of different things to make sure that data is made in a reasonable way. And we came up with a thing that we call the Pemberton scale. It's hopefully a useful tool that everyone will be able to use, that can be used, as people said, within water, within grasslands, within everything in the future. But remember, this is the feasibility. And we've only just done the feasibility for this. So this is a project that Ed, one of our partners on the project, he's around, he's got his pen in the air, he's doing with West Berkshire Council, which is around understanding carbon but also biodiversity, and we'll hopefully do stuff with them in the future. And what do we want to do? So we got this cool tool. We worked out it's possible to measure biodiversity in a validated, verified methodology delivered at value, the 3 Vs, if you will. And we achieved TRL5. What we're now looking for is we're looking for people to help us get this into a bigger idea, a bigger model. We spoke to OS a bit earlier. They seem quite interested. But anybody else that's out there that can help us with a bit of funding so we can release this and actually help people understand and measure biodiversity, it would be amazing. So I've just blabbered at you for 4 minutes, and I'm sorry, I can't talk about all the technicalities about everything because of the short time scale. But if you want to geek out with me about some of the maths behind this or some of the other bits, I'm really happy to do so. And also thank you, as I said, to everybody here and also to our partners that were involved in this project. So Ed from BioCap and TVERC and myself, Alexis from IMGIP. Thank you very much, everybody.
Great, thank you very much. So before we go on to the next project, can I just remind, if anyone is still struggling to get into Menti, I'll remind you, it's menti.com, and the code, if you're missing it, is 4489882. Okay, right, so let's crack on. So climate change needs no introduction. Monitoring its extent and pace, of course, is vital. So in that context, it's a great pleasure to be able to introduce the CC for CC project led by Geospatial Ventures in the UK. And I'm going to ask Paul to tell us what they've done.
Okay, thank you. Okay, so my name is Paul Bhatia. I'm here today as a Managing Director of Geospatial Ventures Limited, a splinter company from a former spin-off of the University of Nottingham that was working on INSAR technology. Nowadays, we're working on geospatial solutions. I'm here representing the CC4CC consortium, which consists of those organizations that you can read at the top there. So the problem, the challenge, the solution, it's in the title. Solution, CubeSat constellation, problem, climate change, and more specifically, sea level rise. So what you can see there in the bottom right-hand corner is predictions of sea level rise at different rates by the end of this century. And here's a problem, if I can get it to work. And this was accentuated at COP27 in Sharm el-Sheikh. It's an island, Pacific island, called Kiribati, I hope I said that right, which no part of the island is more than 2 meters above sea level height. That means by the end of this century, it's going to be underwater. So this is a huge problem all around the world. And there you go. That kind of talks a little bit about that. So what's our solution? Well, the problem is, if you like, there are satellites out there, low Earth satellites, but they cost a lot of money. So 250 million euros to build a Jason satellite and launch it and use it, or the Sentinel satellites that are currently doing ground repeats. In the case of Sentinel, at 12 days, it will be 6 days when the Sentinel-1C, I think it is online. And what we want to do with this project, feasibility project, is to build a constellation of 20 CubeSats that will provide daily ground repeats with 5 centimeter height resolution, 200 meter resolution with the GNSS receiver that we're using. So change that. So there's a number of innovations in this project. It's a daily repeat, a Ka band transceiver from EnduroSat, which allows us to have very high data rates. So when we want to put video, when we want to put images on there, we can do. So like I said, it's a feasibility study. A multi-GNSS SDR, and we're looking at 10% of the price of existing missions. So what have we achieved to date? Well, it's a feasibility study, as I've said, so the mission and systems requirements is done, the system implementation requirements is done, the data management requirements is complete, the Ka band SDR exists at TR level 7, so we're there, we've got to do some bench testing, some integration into the CubeSat, we have the platform, and basically I'll talk a little bit more about what we need to do next. We've had discussions, for example, with Dubai Space Agency, so we can put elements of our CubeSat, some of the payloads, onto DubaiSat. Obviously, you have to apply for that, so we're looking not for next year's launch, but the year after. We're looking for future funding. Our platform has been used already for a proposal for ionospheric scintillation monitoring from space. So we've done some websites. We've created a Twitter, which is really good, actually, because it's created a bit of a community and a buzz and a discussion about climate change. So what's next? Well, it'd be great to talk to Nick and Donna, because Nick's got the money, Donna's got the opportunity, so we'd like to do that. We've got a webinar planned that we're going to do by the end of the year, early next year. We've still got to do the preliminary commercialization plan. We've got a prototype. We need to do some more testing on that. And basically, we need a launch. So that's what we're looking for. Thank you very much.
Thank you very much, Paul. Okay, nautical tourism, a massive part of the economy for many countries, particularly around the Mediterranean. So it's a pleasure to be able to introduce the Diorama project, which is led by Sam Yacht, a Greek company, and I'm going to invite Alex to tell us about it.
So, thank you very much, and good afternoon, everybody. I am Yannis Kostopoulos. I'm not Alex, but no problem. I'm the CEO of SAMI. We are a company specialized in services for the digital transformation of marinas and ports. We are currently serve more than 40 marinas and tourist ports in Greece and Cyprus. So through all these activities, these commercial activities, we have focused on specific challenges that there exist today in this specific vertical field in nautical tourism, as mentioned before. So the basic challenges that we face today is, as you can see, the absence of technologies and systems for marinas, also for the daily operations, but also for the environmental management and monitoring and collection of data in real time. So we believe that ICT technologies and especially drone technologies and Earth observation technologies can help in order to collect real data and help, of course, for the decision making in the daily operations in marinas and tourist ports. So because of this fact, we collaborated with a UK-based company called Sparkworks that is specialized in edge technologies and machine learning technologies in order to deliver an integrated system based on drones that is going to be as a digital assistance for the daily operations of marinas and collection of real-time data in these specific fields. So as you can see, the short description of the solution is we choose different types of drones, and we tested different types of drones and also different types of algorithms for interpreting the real-time data in order to have the decisions about the conditions that we have in marinas in terms of the boat positions, of the appropriate mooring inside the marina, but also in alterations in the water colors, especially when we have occasions like littering and this kind of stuff. So if we go here to some results, and you can see more specific information about what we have done. So we test two different technologies, drone technologies with DJI Mini 2 and DJI Phantom 4 Pro. And we also used specific algorithms for training and for the decision support, that it is TensorFlow, YOLO, and Detectron for this specific solution. Datasets that we collect from different marinas, and also we create our own datasets made and consisted of more than 4,000 images, and in those images we identified more than 25,000 different objects. And we demonstrate finally how small flying objects like drones can improve the travel experience for the tourists, the management of critical infrastructures, and also identify pollutions in marina areas and harbors, as you can see into these two images. So this is a big market that we are going to work in the next period, consisting in more than 10,000 marinas and 6 million recreational boats and 45 billion revenues annually. And of course, if you need to learn more and to have more visualized results, of course, you can visit us outside in the expo area. So here is also my contact details, and we are happy, of course, to discuss more about this project. Thank you very much.
Thank you, Yanis. Okay, now, one of the other ingredients for coastal tourism is clean coastal water. So it's a great pleasure to be able to learn about the Entrust project, which is led by the French company Sat for Space. So over to Joanna, I hope. Yeah.
Hello to all. As you can see, I'm not Joanna. I'm Dionys Grigoriadis. I will present you the Entrust project. I'm from Planet Ekelas. Entrust project is a feasibility study that monitors water quality. The involved partners are Sat for Space from France, Planet Ekelas from Greece, and Microelectronica for Romania. All three partners cover the upstream and the downstream service. The area that we chose was the coastal areas, which have a very significant meaning in terms of the environment, but also have a major economical value. In the beginning, we had to establish some things. The first one was to find and identify which is the legislation that currently covers the water framework. The second was to identify the most important parameters regarding water quality, which was chlorophyll A, water transparency, total suspended matter, and turbidity. Also, we had to research and find which what operational services currently work in Europe. The most important one was CMEMS and Reticus Marine, which is developed by Planetech Italia. Although they offer a constant monitoring for the water quality, the resolution is very coarse. So we had to do a service and market analysis to identify what are the needs of the end user. We came across very oftenly that there is a need of high resolution data and a high revisit time. So in order to fulfill these needs from the end user, we did a comparison between drones and nanosat in order to find which one would fulfill better the end user needs. We decided that nanosat would be more appropriate due to their SWAT area, their constant monitoring, and high revisit time. Now, we had to do certain trade-offs in order to cover the payload options. The one was to use already developed satellites like Hyperscout, or to use a camera that after some modification would fill the needed requirements, like a Pixels. You can, for more details, you can see the proceedings in the last bullet. Now, one of the most important things in the methodology was to implement artificial intelligence and specifically machine learning techniques. This is very important because they can simulate a real case scenario. Also, they can automate procedure, and they can be used for predictions. Now, what is the next step? In this project, we established the baseline. The next step would be to proceed to a demonstration case in order to examine how the theory and the developed methodology can be implemented in real case, both from the hardware and software treatment. Thank you very much. You can contact us in the email that you see, or you can find us in our booth. Thank you all.
Thank you very much. The impact of poor air quality on human health in our cities needs no introduction. It is clear to us all. What is not clear is how we manage that problem. So I'm delighted to be able to introduce the FlyCare project, which is led by Walter, a French company, and I think the person presenting it may possibly be Petros.
Yes.
Ah!
Hello, I'm Petros. I am working for Voltar, a French company. I'm based in Berlin, and I am Greek, as our partners from Geoscience. So we are a European project on our own, you know. So although I'm trying to present the FlyCare, although in 4 minutes I will mostly try to make a good impression. FlyCare is a cooperative project designed by Voltar and Geoscience. Voltar is a French startup that was founded in 2018 in Toulouse as a spin-off from CNES, the French space agency. And our DNA is remote sensing and emission tracking. We are emission hunters, let's say. Geoscience, on the other hand, is a Greek company based in Thessaloniki with more than 20 years of experience. They have out of the shelf offers and tailor-made services. They have an academy for drone pilots. They're amazing partners, and in this context, you may say it was an experiment for us. It's motivation and a startup that is coming like with ideas about taking over the world, and a company that has an experience and knows how to fly drones. So, what we're doing with FlyCare? Well, we monitor air pollution. And what a better way to monitor air pollution than something that can fly. Air pollution, first things first, air pollution is one of the top number reasons in many health issues It is also to be said that it is the easiest way to monitor and mitigate climate change at the same time. This is because the cause, sorry, I need to see this, was a bit a bad slide. We don't have the video? Anyway, yeah. So the reason that you can monitor climate change by monitoring air pollution is that the cause of many air pollutants is the same cause that it's the same cause of many greenhouse gases that are released in the atmosphere. Sorry, I was lost with the demonstration. Anyway, we took a drone, we put a camera on the drone in order to identify hotspots and the key points that you can monitor where air quality, air pollution is coming from. Yeah, I'm lost a bit, sorry. I developed a stage fright for some reason. So what we have achieved is a flexible, cost-efficient, gap-filling service. We have answered to many needs from our prospects and our customers that they couldn't do air quality monitoring because it was a very expensive thing to do for many medium and small-sized cities. It was a very expensive thing to do for many industries that they lack the resources. So we developed a service which is flexible by using drones and remote sensing in order to gather the data that are necessary and provide, feed models, improve models. And I hope I will see you afterwards to explain it better to you, because now, since I'm lost, I will not manage to do it any better. I'm sorry about that. Yeah.
Okay. So, a very different kind of project now, one which is developing a technology that can enable a wide range of applications over sea and over land. So let me, without telling you any more about it and spilling the beans, let me introduce the Forest Project, which is led by Asman Technology in France. I believe Dominique is presenting it.
Thank you very much. Good afternoon. I'm not Dominique, I'm Jean-Louis, and I'm representing the consortium. So, next. Yes, for next?
Should be, yeah.
Yeah, but where should I point it?
Okay.
Okay. Sorry. So basically, yes. So basically, the idea was to prevent fire and support the force firefighters on the ground on a different altitude, which is between satellites and conventional means like aircraft, helicopters, having to go through the smoke also to help these people. And so the best segment was to use the stratospheric balloons, which is part of the HAPS, high altitude satellite. So we combined together with Asman technology, with real-time communication on the ground for data up and down, and also the B2 space platform for stratospheric balloon, with the idea to keep on a permanent area with a so-called semi-persistence. So there is a technology brick which is very essential to control the balloon to stay over a given region. And then we can launch, before the fire season, an eye in the sky that will look and tell the firefighters there is a fire start, go immediately and catch it as soon as possible. And then if it cannot be done, then we can support efficiently the firefighters by seeing where the restart of fire may happen and so on. That was the basic idea. And also, that was also my company defining the payloads to see in the visible and different bands of infrared what's on the ground. But this could also be applicable for maritime pollution like oil budging. It could be also, because of the rapid deployment system with the balloon, can also be an aftermath like earthquake, flood, any kind of disaster on the ground, to have a rapid eye in the sky again. Not launching a satellite, not risking the pilot life or helicopter life if there's bad condition. So we learned a lot of lessons. The result also is very promising because we can achieve a good resolution on the ground to detect flame in the, let's say, in the below 20 square meter, sorry. So 20 square meter, we can detect fire with the optics we define with infrared. And also we learned a lot, first cooperating across the border with people in UK and also with a lot of Spanish team, so this was intercultural. And we have also faced some, during the project, the impact on the global economy, like the scarcity of electronic components, like also the rise of price, like helium also is rising price. And then we also discover a very good market momentum and interest from the various users about this technology, which are, we are under scrutiny to see if we can validate these essential bricks to get a balloon into a semi-persistent way on the atmosphere to cover actually a range on the ground that is between nanosat or geostationary and the conventional aircraft and so on. Our point of contact are here, and we can show you some video and discuss with you on the booth. Thank you very much for your attention.
Thank you very much. So now we have a project which was postponed from this morning, if you may remember. There was a delay in travel. So, and it's a project a little bit similar to the last one in terms of being a technology with lots of applications based on CubeSats. So I'm going to introduce the clever demo, and it's going to be presented to us by Florent. Over to you. Thank you.
All right, so as you probably know, satellites generate tons and tons of data every day. We're speaking about gigabits, tens of gigabits, hundreds of gigabits of data every day. And that consumes time, that consumes money, and quite paradoxically, usually the end result is quite light. When you are just monitoring deforestation, you are interested in a very small amount of data in the end. And so the team at the Space Center at the University of Grenoble, the CSUG, is pushing the technology of machine learning to put it on board the satellites, and namely nanosatellites, based on a core processor called the Core Minnow, made by Teledyne, and a demonstration around a camera with a sensor also made by Teledyne with an emerald. It's called Emerald, hence the name Clever, with a Q for Core Minnow and E for Emerald. And so the team built an engineering model in order to demonstrate the capability, you have it over there, the capability to actually put it all together, put it all in real time, and have it one step closer to bring it into space. And in parallel, U-Space, the space nanosatellite manufacturer in Toulouse, we are designing the satellite that will carry the demonstration on board in the coming years. And I think, yeah, I have even a small animation of it. And so if you're interested in knowing more about the mission, about the technology, please contact either Tanya, head of the project at the Space Center, or myself regarding the nano satellite. Thank you.
Okay. Just stay there, Florent, because Florent is also going to introduce the next project, which is called Response. We've heard quite a bit about climate change, but what we haven't heard about is how we can measure where the greenhouse gases are being emitted from and where they are being reabsorbed. So the Response project is aiming to help with that problem. So back to you, Florent.
Thank you. So yeah, a couple of weeks after the COP27, I guess you are all aware of how paramount it is to monitor CO2 emissions around the globe. And that's the objective of our lead company, Ever Impact, who is focused on monitoring CO2 emissions both for collectivities, so for small cities, big cities, and for businesses. And so the project has been built on three main pillars. One is the demonstration in the pilot city of Dijon, with a deployment of, I think, 77, I don't know the figure here, no, 77 sensors across the city in order to monitor CO2 emissions year long. The second pillar is to develop the dashboards to action the data, to make it understandable and to provide actionable data for the stakeholders of the city of Dijon and more to come. The third pillar is to scale up the project and actually have sensors in space so we can monitor globally the CO2 emissions. And so the team is continuing the developments of the space systems, and we will hopefully enter the development phase mid-2023. And if you have further questions on CO2 emissions and the role of Ever Impact in climate change and climate monitoring, you can contact Alain Rétière from CTO of Ever Impact. And if you want more details on the satellite itself, you can contact myself, Florent Hénard from U-Space. And here you see the future satellite to be built. Thanks a lot for your attention.
Thank you, Florent. Okay, from carbon emissions managing to avoidance of emissions at source through decarbonisation. We're all familiar with the growth of offshore wind farms, particularly in the UK, but also increasingly in many other countries around the world. And maintaining them is a big challenge. So I'm delighted to introduce the Saturn project. It's being led by UK company Airborne Robotics, and Alex is going to present it to us.
Thank you. So, thank you very much. Welcome, everybody. My name is Alex Verserfeld. I'm the CEO of Airsoc Systems. I have with me Keegan, who is our project manager in R&D. So Project Saturn is all about offshore wind farm inspection via drones. And we are addressing a huge market, which is very important for the UK. It's growing very fast internationally, the offshore wind energy market. Sorry for that. There we go. It is a great market, but it comes with one problem, which is high, as mentioned already, high O&M cost. And they are budgeted currently at 75 million per 1 gigawatt production, which is about 100 wind towers or 100 turbines. But there's a good news. We have a solution for it. And the solution is we have a drone stationed on a helipad out in the wind farm. It is connected beyond visual line of sight via SATCOM communication, and it does autonomous
flights throughout the wind park and transmits all the data and can be remotely monitored. So it's a way to deal with it in a green way. It's a way to do it safely, cost-effective, and it brings a lot of digital data. Okay.
So to discuss the project objectives in order to achieve remote navigation, the first thing we started to outline was designing a user-friendly end-to-end autonomous system. So this system would comprise of our UAV drone integrated with a SATCOM technology. It would also include our cloud-based battery health management system, as well as sensors, and then the entire systems architecture. The next thing was then to do the testing phase, which is stated here as our use cases. So this was doing and completing an onshore and offshore test. And then finally was data. So in terms of validating the data, we achieved 500 milliseconds of data of latency, which is what we consider to be relatively low, at a rate of 22 kilobits per second. In terms of the partners that were involved, or our consortium, Airborne Robotics being the first, we were responsible for drone technology, for systems autonomy, as well as BVLOS capabilities, beyond visual line of sight capabilities. The next was our European-based partner, Atmosphere. They were responsible for satellite equipment and the low Earth orbit equipment as well. Lastly was the University of Portsmouth, and they were tasked with handling the battery health management system.
So talking about the results, we have customized one of our Air 8 drones. It's a fully redundant drone, so all the elements, the essential elements are twofold. We have integrated the Atmosphere SATCOM module. We have basically created a control center environment, and we are able now to autonomously inspect wind turbines. At the same time, we've also built up a simulation environment, as you can see here, an example. Collaborative projects open ideas and basically bring new perspectives. We found a partner throughout the UFO network, and we created a product together, but also optimized our own products.
In terms of moving forward, just to speed things up, in terms of moving forward, we are looking for new investors continuously as we continue to develop, as well as customers and partners. So if anyone is interested, we are looking to expand and to continue to network with the rest of the participants here today. So thank you very much all for your time, and yeah, we look forward to chatting with you in the exhibition area. Thank you very much.
Okay, thank you, guys. For any electric vehicle, range is always an issue, as I'm sure electric car owners will be only too aware. And it's also an issue for drones. So it's a pleasure to be able to introduce the CDROMS project, which is led by the Hellenic Technology of Robotics organization in Greece, to talk about the technology that they've been developing. Spiridu, over to you.
Hello, I'm Spyros Makris. So we were involved in the CDROMS project, which had the principal goal of increasing the range that an operator in the sea can observe. And the application is maritime surveillance, although we do believe that this can extend far beyond that space. So our solution was to, instead of using a drone, a quadcopter or octacopter and so on, is to use a plane that can be energy efficient and then fit solar panels on it. We saw today Zephyr in the ESA presentation. That is a really large vehicle that can achieve energy autonomy. This, however, is a vehicle that's only 2 meters wide and can carry sensors, can transmit data to the ground, and can fly semi-autonomously, at this point at least, without having to land for quite a few hours, depending on the weather conditions. We have demonstrated more than 4 to 5 hours, which is way beyond what you would find in the industry. we had to go into the details of how the actual plane is designed and had to run a lot of simulations in the aeronautics department and the energy generation and transmission and storage department in order to achieve this. Turns out it's a rather hard problem, but our results were rather promising, so eventually we did build 2 planes to demonstrate these capabilities and also had the data in a ground station that can take all the data from cameras, then create a 3D visualization of where you're flying, and then live, like in real time, display where your assets are. So in our example, it was only a couple of assets, but in a future example, in our next steps, we are envisioning constellations, or let's say swarms of this kind of aircraft that can carry around sensors, carry transponders, and basically achieve perpetual motion and perpetual flight. So if anyone wants to use this beyond cameras and so on, you can find me, or you can contact us through these details. Thank you.
Thank you very much. Our last pitch. Weather forecasting, and I should add sea state forecasting, are becoming increasingly vital to all sorts of operational planning. And the quality of those forecasts depends very much on the richness of the data resource which drives the models. So it's a very interesting project which I'm able to introduce to you as our final one, and it's a project called TMOS, which was being led by the UK company Voltitude, and I'm going to invite Paul to come and introduce it to us.
Hello, thank you. Good afternoon. My name is Paul Stevens. I'm the CEO of Voltitude, the leader of the project TOMOS, which stands for Targeted Meteorological Observations from the Stratosphere, and we collaborated with Formtech Composites Limited, both companies from the UK, to make this ambitious project work. So in terms of the challenge, the climate emergency is presenting a greater occurrence rate of extreme weather events. These extreme weather events are threatening our society, and they certainly threaten our entire global economy. And the need for more accurate weather forecasting, not just more accurate, but longer range forecasting, is ever more present and needed. So the globe is covered very well by hugely valuable space-based observation data. They provide excellent horizontal coverage, and without those, we would not be able to produce the high-quality forecasts we have today. However, if you talk to meteorologists in operational frontline forecasting stations and say, where are the greatest source of error growth in your models? Why can't you tell me what the weather's going to do in a month's time? Why not 2 weeks' time? And they'll point to the remote areas of the globe, the polar regions, the ocean regions, regions of landmass where the countries can't afford upper air observation systems. Those are the sources of greatest error growth in our models because they don't have very fine, high quality, high vertical resolution weather data. And so the challenge is clearly set. Our solution was to really reinvent quite an old technology, which is to miniaturize dropsondes. Dropsondes are a meteorological observation data package dropped out of aeroplanes. They fall to the ground, taking observations, and radio that data back to the plane that dispensed them. Well, what we did was miniaturize the measurement circuits that are used to drive those sensors and take advantage of the latest in battery technology to put really small batteries on these tiny dropsondes, which only weigh 20 grams, and design them so that they could be stacked in large quantities in very low mass and compact ways, such that they could be installed and fitted on stratospheric platforms. The project originally targeted fixed-wing solar electric, but during the test and evaluation phase of our demonstration project, we stumbled across a new product, a very lightweight, long-endurance balloon fitted with a venting system that allows it to control its height and a ballasting system to control its altitude fully. And this small, lightweight, disposable and biodegradable balloon system is the perfect delivery system for our dropsondes. It's very simple, really. The dropsonde released from the stratosphere falls all the way to sea level, transmitting very high-resolution data of temperature, humidity, wind field, and pressure back to the platform that dispensed it, and we then use Iridium's short-burst data service to relay that to our computer servers and distribute that to end users. The collaboration was a natural teaming event. I'm pleased to say that we're continuing to work with Formtech Composites on new opportunities, and I'll just move forward to some of the benefits from our project. So a big lesson for me was how powerful grants like UFO funding has been. It's been a terrific door opener for us. It allowed us to collaborate in an environment we otherwise wouldn't have been able to. And it also allowed us to reach out to end users in a way that perhaps we wouldn't have been able to as a private company, self-funded. We are looking to commercialize our product. We've achieved TRL 7, and we are seeking private investment to help us industrialize both the manufacture of the balloon and drop-on system as well as the operation. I should note also that our balloons have an endurance of over 7 days, and they can drift to very remote areas of the world very efficiently with very few launch locations to provide global coverage. So come and see us next door. You'll see us because there's a big balloon on our table, and we'd like to discuss this further with you. Thank you very much.
Well, thank you, everyone. That's been a fascinating afternoon of really interesting projects. So I think now it's time to hand back to Luca.
Well, thank you very much, Jonathan, for the excellent moderation. We now come to a close with the second session of pitching, of presentations, and well, it's wonderful to see the breadth of solution that's being proposed by all these entrepreneurs, all these innovators. We now, well, we're almost at the closing remark now. We are going to do some closing, and after that we're going to have a one-to-one meetings for those of you that have organized meetings to discuss potential collaborations and get to know the application of the technology. At 4 o'clock, we're going to delay the drink reception, as at 4 o'clock we're going to have our prize ceremony. We need to bring it early a little bit, and that will be hosted in the main, in the map room, or in the main hall, actually. And then we're going to start having some drinks and continue networking. And then by 5 o'clock, we should be able to be out of the venue. I'll leave it now with Andy to also leave some remarks on to end the event.
Thanks, Luca. I think all it comes down to now is thank yous, really. Yeah. So thank you very much to the hosts here, the Royal Geographical Society. Thank you to all the people who've pitched today, all the projects, all the successful projects. Can I just say, for all of those, please do come up at the end because we're going to get a photo of you all at the end. Thank you to our speakers, our keynote speakers today as well. It's wonderful to hear from the wide variety of organisations and the funding and the opportunities available through those as well. And finally, thank you again to all the amazing partners that we've been involved with throughout this project. It's been a really great team and collaborative effort, and it's been an absolute pleasure of mine and Luca's to be part of this consortium delivering this UFO programme. So I think everyone deserves a massive round of applause. Thank you very much.
Well, this is the end. We'd just like to see all the innovators here on stage for a photo. Everyone else can move on the main hall where we're going to have continue to have networking and then the prize ceremony. Thank you.